Hi guys, my name is Bappy and you are welcome to my YouTube channel. So guys, in this video, I'll be developing one end-to-end multi-agent AI application with help of LangGraph, model context protocol. Even I'm going to use supervisor agents, guardrail safety, as well as HITL, that means human in the loop. So whatever advanced topic we have learned so far inside our Agentic AI playlist, we'll try to use all of the advanced topic and we'll implement this particular project completely end to end. So if you are new to my channel guys, please try to check my playlist. I have created a complete Agentic AI playlist and link is given already in the description section. From there you can check it out. So this is going to be a complete end-to-end implementation. So here I am already expecting you are familiar with all of the Agentic AI concept I have covered. This should be the prerequisite only for this particular development. So if I show you guys, this is my complete playlist. As you can see in this playlist, I have covered each and everything you need to know about Agentic AI. Even I have also implemented so many end-to-end project. And now in this video, I'm going to create another end-to-end project and we'll try to combine each and everything we have learned so far. And the main things we'll be learning here, the guardrails safety part, as well as the supervisor agents part. Okay, we'll try to integrate these things inside our multi-agent system and we'll be developing this system completely end to end. So guys, this project I have divided into multiple parts. I'll be implementing this project in 3 parts. Okay, like in part 1, we'll try to create this simple multi-agent system without using the model context protocol. And part 2 will be using model context protocol. We'll try to integrate the model context protocol inside our multi-agent system. So this is the architecture for that. And in part 3, I'm going to use supervisor agents as well as the guardrails and HITL, that means human in the loop, and we'll try to implement this kinds of entire end-to-end system, okay, so that our agent would be more advanced, more robust. Okay, so if you see this advanced architecture guys, this part 3 architecture. So here, whenever user will give the input, first of all, we'll try to apply the guardrails verification. We'll try to check whether this input is having any kinds of harmful or let's say any kinds of violation related content or not. If it is having this kinds of harmful violation related content, we'll try to block that particular request. And if it is like safe and relevance for this particular problem statement, we'll try to accept this user input and we'll pass to the supervisor agent, and supervisor agent will try to decide from my specialized agent what are the agents should be responsible for completing this particular task. Okay, because here you can see I am having multiple agents like flight agent, hotel agent, weather agent, budget agent, okay, itinerary agents and final agents. So user is giving let's say if user is giving a input, I need to book a flight in this particular country. That time only these hotel agents and itinerary agents should be, or budget agent should be executed. I don't need flight agent and let's say weather agents that time. Okay, so if I'm executing all of the agents in parallel, that means you are actually ending with lots of cost, right? Because every agent involves one particular API calls, or let's say any kinds of LLM calls. That's why to minimize the cost, you can use the supervisor agent, and supervisor agents will automatically decide for the given input which agent should be executed, okay, in which order. So that's why this supervisor agents will be using, and it will automatically select the agents based on the user prompt. Okay, then we'll implement all of the multi agents like flight agent, hotel agent, weather agent, budget agent, okay, itinerary agents. Then we'll try to also create a shared state, okay, that is the state memory, and we'll try to integrate everything in the human in the loop. That means once my draft is ready, instead of let's say finalizing the output, it will first of all ask for the human verification. If human approves that, then it will be finalized, otherwise user can change it anytime. Okay, then we'll try to maintain all of the state memory and the checkpoint inside the PostgreSQL database. Okay, so that means these are the new things. We'll try to add the input guardrails, supervisor agents, as well as the human in the loop concept, okay, in this particular development. So many people has requested that sir, how we can add the guardrails, supervisor agents, okay, and human in the loop concept inside the multi-agent system. So I think this project will clarify each and everything. So make sure you watch till the end. And if you have any question, please try to comment in the comment section. And if you found my content useful guys, please try to subscribe to my channel. And please try to share this with your friends and family, because I need your support. If you're supporting me, definitely I can bring this kinds of content more in future. So one things actually I want to tell you, I think you have already watched this particular implementation. TripMate AI. Okay, this was one of the project actually I implemented inside my playlist. So what I'm going to do, I'm going to implement the same problem statement, okay, with this three architecture, the architecture I showed you. The part one architecture, first of all, we'll try to implement the simple workflow with the help of this LangGraph. We'll try to create the multi-agent system. Then we'll be in the part two, we'll be using model context protocol. I'm going to show you how we can integrate the model context protocol, that means MCP, okay, inside this particular multi-agent system. Then in part three, I'm going to show you how we can add supervisor agent as well as the guardrails, okay, safety or guardrails security inside our multi-agent system. Even we'll also add the human in the loop concept, so that whenever it is preparing the draft for you, it will not finalize that, it will ask for the human verification. Once human will approve that, it will be giving you the final output. Otherwise it will ask for the feedback, so that you can change this particular draft anytime. Okay, so this is the architecture we'll be developing, guys, completely end to end. So if you're already familiar with this implementation, so I think you will be loving this project a lot, because I'm going to implement this project again, okay, from the beginning, and I'm going to use these are the advanced technology, okay, advanced topic, so that you can learn the entire workflow of a multi-agent AI system. Okay, now you can ask me why I have taken this problem statement, because I felt this problem statement would be good fit for me to explain the entire like architecture, the entire technology. That's why I have taken that, because you are already familiar with these are the concept, okay, that's why I've taken this particular problem statement. But don't worry, I'm going to create more end-to-end multi-agent system, okay, and there I'm going to use any other problem statement. Okay, so problem statement doesn't matter, the matter is how we can add these are the advanced technologies, okay, inside the multi-agent system. If you can learn that, you can integrate this thing with any kinds of project, okay, any kinds of problem statement. That would be best for you. Okay, so that's why I'll be taking this problem statement, because I started this playlist and I wanted to keep the flow on. That's why I'll be taking this example only. Okay, so guys, let's start the implementation. First of all, we'll try to understand the problem statement. After understanding the problem statement, we'll start the development. So first of all, we'll be working on the part one, that means simple workflow will be developing, simple multi-agent workflow will be developing without using any kinds of MCP. Then we'll be using the MCP, then we'll be integrating the supervisor agent, guardrails, and HITL. Okay, so this is the entire plan for that. So guys, before starting the development, first of all, let's try to understand the application overview and the application architectures. So as you can see, TripMate AI, this is the LangGraph multi-agent travel planner system. So you can see this is a multi-agent travel planner that turns a natural language trip request into a practical travel plan with flight suggestions, hotel ideas, and day-to-day itinerary. The projects uses a multi-agent workflow built with LangGraph. And why this project? As you can see, planning a trip usually means jumping between multiple websites, tools, and spreadsheets. Okay, as I already told you, let's say if you're planning for a trip, right, you have to visit multiple websites to look for the flights information, hotel informations, right? Then which location you just need to visit there, right? These are the things you have to explore, and you have to take a notes on the spreadsheet or anywhere. Then you will be making the entire plan. So this takes lots of time, right? And it needs lots of exploration. Even sometimes you may miss out anything, right? So this project brings that flow into one experience by combining a flight search agent, a hotel research agent, and itinerary planning agent, and if final response agents, okay, all coordinated through a LangGraph workflow. That means in a single place, we'll be combining all of them, and each of the task would be mentioned to each of the agent. That means for the flight search operation, we will be creating an agent. For hotel information, we'll be defining another agent. For itinerary planning, we'll be defining another agents. Okay, for final report generation, we'll be defining another agents. That's how we'll be creating multiple agents together, and those agents will be those agents will be responsible for generating the entire trip summary for me, okay, trip plan for me. So that's why we call it as a multi-agent system. So here we are not utilizing one agent, we are using multiple agents, and each of the agents will have some kinds of tools to complete that particular task. Okay, so here is the entire like architecture, guys, as you can see for this project. So first of all, I already told you here we'll be utilizing multiple agent. As you can see here, we'll be utilizing multiple agents. The first agents will be creating the flight agents. Okay, so basically this will search the flight and finds the best option for visiting location A to B. Okay, and for and to get these kinds of flight informations, it needs some tools, right? And here we'll be using Aviation Stack API. So this Aviation Stack API, what it can do, it can search real-time flight informations, right? And it will give you that particular flight informations to the flight agent, and flight agent will try to utilize that. Okay, so optionally you can also use Tably search here, but I feel like Aviation Stack is having all kinds of flight integration in one place, so that's why we'll be using Aviation Stack API key here. Then second agents will be developing these hotel agents. So what this hotel agent will do, it will search hotels and compares options. That means it will only look, it is not only going to look for the agents, it will look for the best hotels for you. Okay, best hotels with respect to your budget, right? So this hotel information it will try to find, and for this we will be using some kinds of tools, right? And here we'll be using Tably search. Okay, so Tably search, with the help of Tably search, we'll try to figure out the best hotels from that particular location, and we'll try to give the suggestion. Optionally you can use the Google Place API. This is optional, but I'll be using Tably search, okay, because this is completely free to use. Then the next one, itinerary agent. So this basically creates the day wise itinerary. That means where you have to visit, okay, what are the activities you have to do there, what are the best places, okay, each and everything this particular agents will try to get it for you. And again, to get these are the information, the best visit location activities, will be using Tably API key again. Okay, so with the help of Tably, will perform the internet search operation, and real time will get the information, and it will try to use this information in my itinerary agents. Then fourth, I'll be using this final response agents. That means it will be using all the information, and it will try to prepare the entire plan for you, entire trip plan for you. Okay, that means it combines all the information and generate a final response. And again, for this we'll be using a large language model, and the large language model wise we'll be using Llama 3. Okay, and we'll be using Grok provider. I think you know Grok provides some free limits. Okay, you can generate API keys, and you can access some model, okay, completely free. You don't need to pay for that, but there is a limitation, but it's fine. Okay, for this particular task I will be using this free API key, but if you want you can also take the subscription. You can use some premium model. It's completely up to you. Okay, so yeah, we'll be using this Grok provider here. Yeah, then you can see each of the agents will be connected to a shared state, that means shared memory, and we call it as a state. If you are already working in LangGraph, I think no, there is a concept of state, right? We have to create the state, and these are the state I need, guys. Okay, I need user query. That means whatever user will pass, I'll save inside the user query. Whatever flight results I'll be getting, I'll try to save in the flight results. Whatever hotel results I'll be getting, I'll try to save in the hotel results. Whatever itinerary response I'll be getting, I'll try to save inside itinerary results. Whatever final response I'll be getting, I'll save inside final response. Okay, and whatever my agents will try to reply, okay, that entire plan I'll try to save inside my message state. And this shared state will be storing inside one amazing database, guys. We call it as a PostgreSQL. Okay, so this database will be using for my memory. Okay, memory purpose will be using. That means we'll try to store all of the checkpoints, all of the conversation here. Okay, so it will basically have the conversation story, user preferences, agents output, and state updates. Okay, so this is the entire architecture, guys. We'll try to follow, and we'll be implementing this entire agents. Okay, I hope you get it. So guys, as you can see, to develop this entire application, I need the 4 agents here, the flight agent, hotel agent, then itinerary agents, and the final response agents. Okay, so we'll be developing 4 agents, and we'll try to combine them all together, and this will become a multi-agent system. Okay, yeah. So first of all, to implement this entire system, guys, what I need to create my GitHub repository. So there I'll try to create a repo, and I'll start writing the code. So for this, let's open up my GitHub, guys. I'll open up my GitHub. I'll go to my repository, and let's create a new repo here. I'm going to give the name of this repo. So what I can do, maybe I can copy this name, and I can give it here. Okay, let's say this is my name, and simply I'll just try to make it as public. I will add the readme file. Git ignore wise, I'll be taking Python. And license, let's take this MIT license. Okay, you can take any license, it's up to you. Okay, everything is fine. Now simply what I'll do, I'll just try to create this repository. Okay, so my repo is created, guys. Okay, next thing, I'll just try to clone this repo. I'll just click on this code and copy this HTTP URL, and I will open up my local folder. So here I'll open up my terminal and let's clone it. So git clone, paste that URL. So it has already cloned my repo. So now I'll go inside that. So cd, the name of the repo is strip mate AI. Okay, so now I'm inside this folder. Okay, now here I'm going to open up my Visual Code Studio. Okay, perfect. So here I already moved my architecture file, which is demo.excalidraw. So here I'm using excalidraw file format. So for this, you have to install one extension called excalidraw. Okay, excalidraw. So this is the extension you have to install. So if you install, you will be able to open this file, guys. Okay, and here you will be getting this architecture diagram. So fine. Yeah. Now, next, guys, what I have to do, I have to first of all create the environment, and we have to create the folder structure. So to create the environment, guys, here what I can do, I can write this step. How to run. First, create the environment. Virtual environment. So to create the virtual environment, you have to use this command. Conda create -n. Then you have to give the name of the environment. I will give, let's say, travel. Then I'll give the Python version. So Python is equal to 3.11. Okay, I'll be using 3.11 and -y. That means I want to give the permission. So this is the command you have to use to create the environment. Then second, you have to activate the environment. Activate the environment. So to activate the environment, you have to use this command. Conda activate travel. Then next, you have to install the requirement file. Install the requirements. So we'll be using this command. So pip install -r requirements .txt. Okay, so yeah, these are the steps we have to follow. So first of all, let's create the environment. I'll copy this command and I'll open up my terminal. That's clear. Let's create the environment first of all. Okay, there is a space I have given, but the space should not be there. It should be -n only. Okay, now copy this again and execute it here. Okay, done. Now I have to activate the environment. So this is the command. See, I have activated. Now I'll be installing the requirements, but for this I need to create the requirements file, requirements.txt. Okay, so here I need to mention all of the requirements I need for this agent. So I already noted all the requirements I'll be using. So these are the requirements, guys. I need LangGraph definitely to create the agent workflow. LangChain you need, because if you want to use LangGraph, so LangChain is the dependency, and whenever I want to load any large language model and all, right, I have to use the LangChain there. Then we'll be using Grok provider, that means LLM provider. That's why we'll be installing LangChain Grok. Then LangChain community is also required. Then we'll be using Tably search tool. We'll be using LangChain Tably. And I told you I'll be using PostgreSQL database. For this, I need this PS Y copg binary. Then this pool. These two things I need. Okay, for this database. Okay. Database, and another thing I need this LangChain checkpoint Postgres. Okay, these are the dependency for the database. Okay, then python.env to manage the environment credential. So let's create this .env file. Okay, here we'll try to mention all of these credential, secret credential. Then tably python you need, request library you need. I already told you about the Postgres, right? I will save my checkpoints in the Postgres database. That's why this LangGraph checkpoint Postgres is required. Then I'll also get the I mean flight information, right? For this I'll be using one package called airports data. So inside airports data some informations are available. We'll try to utilize that. Then I'll be considering all of the country, right? Whenever I'll try to search for the flights. So that's why there is another package called PyCountry. So inside that all of the country informations are available. We'll try to also use that. Then fast API for my entire backend and front-end development. Then fast API dependency is UVCon. With the help of UVCon, we'll try to launch the fast API server. Then the Ginger 2 templates. Okay, so these are the requirements, guys, I need, and I already mentioned all of the version. Okay, and you should also mention the version. Otherwise, what will happen? Let's say if you not mention the version, so if you're running this project after 2 months, there is a possibility one of the package will get update and that functionality will be deprecated. Okay, that time you will get the error. So that's why it's necessary to add the version. Okay, this is super important. Now let's install the dependency. So I'll copy this command and I'll try to install the dependency here. Okay, let's wait. Once it is installed, then we'll try to see the next step. So apart from this dependency, I also need to install some other tools as well. Let me show you. So installation is complete and there is no error. Okay, it's completely fine. Now guys, what I need some more tools. Okay, I told you we'll be using this PG admin to see my tables, right? My conversation checkpoints. Even you can also see the different conversation it has saved, right, in the memory. So you can able to see that because I'll be creating this Postgres server on my render cloud, and to see that I need this PG admin. Okay, PG admin, this graphical user interface. We have to install that. So let me close my PG admin and let me show you how to install this PG admin. So if you want to install the PG admin, guys, only in just Google, just try to search PG admin. Okay, PG admin download for Windows. So this is the website. Just try to visit. Or you can directly search like Postgres download. Okay, Postgres SQL download. So this is the website. Here just try to choose your operating system. Let's say I'm using Windows. You can also select other operating system as well. And there is an option called download the installer. Okay, now you have to choose which one you will be downloading. So make sure you are installing the latest one. Okay, 18.4. So here is the download option. Just try to click here. It will start downloading that. Okay, so this is the file, guys. You have to download. Okay, this is around 400 MB. You can download. So for me, I already downloaded. I'll just try to cancel it. So once you have downloaded, guys, in the download folder, you will see this file, this PostgreSQL, okay, installer. Now you just need to double click and install this software, okay, inside your system. So I think you know how to install any software. Okay, the way you install any software, just try to double click and do next, okay. It will ask for password. Okay, you just need to set the password and you can complete the installation process. Okay, so once you have done the installation, now simply you just need to search for pgadmin on your search bar. Now you'll be able to see these kinds of application. Now let's open it up. Okay, so this kinds of interface you will be able to see. See, this is my pgadmin. So for me, I already connected with the server, that's why it's coming like that. But for you, it would be completely different. Okay, so maybe I can close this. So for this, you will be getting this kinds of window screen, or welcome screen. Okay, so now what I have to do, guys, I have to set up this Postgres server on my render cloud. Okay, because I told you for this persistence memory we'll be using Postgres, right? So how to install this Postgres server on the render cloud? Let me show you. So here I'll just visit the render. Okay, make sure you have an account on render. If you don't have an account, please try to create one account. For me, I already have the account. I'll just try to go to my dashboard. Let me close these at the tab. So here to launch a Postgres server, guys, you just need to click on new, and there you will see one option called Postgres. Okay, Postgres database. Let's try to click here. So give the name of that Postgres. I'll give, let's say, trip agent. Let's say this is the name I have given. Now you can give the database name. So I'll give, let's say, I'll give trip memory. Or let's say agent memory. Okay, now you have to give the user. So I can give my user ID. You can give your any unique user ID here. I have given ENT-Bappy. Then everything just keep it default. No need to change anything. Just here in the plan option, you just select the free instance. Okay, so render provides actually free instance. You can use the free instance to launch this server. Okay, and if you want to take the subscription, you can also do that. But in free instance, there is a limitation. I think after 7 or 14 days, I think this instance would be deleted automatically. And here you are getting 256 MB RAM, 0.1 CPU, and 1 GB storage. Okay, I think this is enough for our learning. But whenever you are creating any real world application, my production grade application, whichever you will be using, right, that time you can take their subscription plan. Okay, no need to take the free instance that time. So yeah, everything just keep it default and simply just create the database. Okay, it's giving one error because previously I also created one Postgres server, right? So first of all, I have to delete that one. So maybe I can delete that one. So this is the database I created, right? I'll just try to delete that. So if you're doing for the first time, right, you don't need to do that. It will create. But for me, I created previously. That's why it's coming like that. So I'll just try to delete it. Done. Now maybe I will be able to create that. All the informations are fine. Let's create a database. Okay, now it is getting created. Okay, now let's wait. This starter should be active. Once it is active, then we can use this database. Okay guys, now you can see status is available. That means my Postgres server is running successfully. Okay, you can check there. You can go to the dashboard and you can see it is available and this is running. Okay, now I have to connect this Postgres server with my PG admin so that I can see all of the table inside that, all of the database inside that. Okay, whatever I'm going to create later on. So for this, what I can do, I can go below and there is a URL you have to copy. This is called external database URL. Okay, so render tells you if you are connecting this server in an external service, that means right now I'm using PG admin. This is the external service. Okay, this is running on my local machine. So for this I have to use external database URL. Okay, but there is another one called internal database URL. As you can see, this is the internal database URL. This is only required whenever you are deploying this project. That means let's say I am deploying the same project in the render cloud. Okay, and I'm using render Postgres server. That time I will be using internal database. Okay, so if you're only running your application in the same render cloud, that time internal database should be used. Okay, database URL should be used. But if you're running from the external one, you have to use you have to copy this external database URL. Okay, now let's try to copy that and make sure you don't share this URL with anyone, otherwise they will be able to access your database. Okay, I'm going to delete the instance after this recording. That's why I'm showing you. So I'll copy this and what I can do, maybe I can save it somewhere. I will save this inside my readme file. Okay, so this is the information I have. So this information I need to connect with my PG admin. So now let's open the PG admin. So there is an option called server. Just try to right click and there is an option called register. Okay, just click on register and there is a option called server. Now here you just need to give the name of the server. So I'll give travel agent, or let's say tripmate server. I'll give my application name tripmate. So this is the name, tripmate. Tripmate. Okay, I'll give tripmate and just keep it as it is. Okay, then there is an option called connection. Just click on the connection and here you have to give the name. Okay, host name. And where you'll get this host name should be this one. This should be the host name. See, after @ right, whatever you have, just try to copy till .com, render.com. This is your host name. Just try to copy and provide it here. So this is the host name. Okay, now by default this Postgres runs on port number 5432. No need to change this. Now you have to give the database name. Okay, so what is the database name? So here is the database name, agent memory. So let's try to copy this. This is the name. You can also verify. Simply go to the server and here is the database. Okay, so this is the name actually it has taken for the database. So I have given agent memory, but it has added this 68K5 because it should be unique name. Okay, that's why this information has added. Okay, just try to copy this and add it here. Okay, now it has it is asking for the username. So what is the username? I think remember I given the username ENTBappy. Okay, you can also verify in the Postgres server here. So username is ENTBappy. Let's copy and paste it here. Now I have to give the password. Okay, where will get the password? Here is the password. This is the password. Okay, let's copy. Even it is also available on my URL. So this is the URL. Okay, this is the password. Let's try to copy and paste it here. Okay, then just try to activate this one, save password on, and yeah, everything is fine. Now simply let me check everything is required or not. No, I think everything is fine. Now I'll just try to save this information. See, Once you will do that, it will be connected to the render Postgres server. Okay, now you can expand it. Now you can click on database. Now see this agent memory 68K5 agent memory 68K5. Okay, this database I can see because this is already connected. Now whatever tables you will be creating inside that, it would be available inside pgadmin. Okay, I can see all the tables. So this is the table. Now we can refresh and simply see. Right now there is no table we haven't created, but once I will try to create the table, you will be able to see all the tables. Okay, all of the conversation will be available. So see, so far we have connected our Postgres server with my pgadmin. Now right now you have the graphical user interface, and from there you can see all of the tables you will be creating going forward. Okay, so that means my Postgres installation is completely done. Postgres setup is completely done, and this is running on my render cloud. Okay, I hope you get it. So guys, we have successfully set up our Postgres server on the render, and we have connected with our pgadmin, and this is running completely fine. Now I need to set up some additional, let's say, keys, which is required for this development. So first thing, I need the aviation stack API key. Okay, aviation stack API key. Then I need grok API key. Okay, first of all, let's collect the grok API key. Okay, our LLM provider API key, because here I told you I'll be using a Meta Llama model. Okay, Llama 3 model from the grok provider. Then I need Tably API key. Then I need my database URL. Okay, that means my Postgres database URL, and we already copied the URL. I think you remember that external URL. I'll just try to copy this as it is. Let's cut it. Okay, and I'll try to save inside this variable. So this is the URL. Okay, so with this URL, my Python client will be able to connect with my Postgres server. It will store all of the conversation there. Okay, so make sure you copied this external URL. The URL we just copied. Okay, external URL, this one, and try to save here. Okay, then I need some other things like my Langsmith API key and tracing. These are the things I need. Let me show you. Because to monitor, to trace the entire application, we'll be using Langsmith. So this is the Langsmith. Okay, Langsmith tracing, it should be true. Langsmith endpoint. So this is the URL you have to provide, and Langsmith API key we have to collect. Okay, so let's delete this API and I will collect my own API. And Langsmith project name. So let's say I'll give travel agent. Okay, or let's say I'll give my project name, which is TripMate AI. Let's say this is my project name. Okay, now let's collect all of the API key one by one. Okay, one more thing I have to add, which is the default origin data. Default origin data means, let's say here the things you have to do, you have to give the location A to B. Let's say you want to visit India to Thailand, right? So India is your origin, right? And Thailand you want to visit. So by default, if user is not providing origin, let's say user is giving the prompt like that, I want to visit Nepal. Okay, so you are not giving the origin here. So by default, you can set the origin here. Okay, let's say which your origin. So let's say I'm from Dhaka right now, so I'll give DAC. Okay, that means Dhaka. So from Dhaka it will plan to the different country. Okay, that means Dhaka is the origin right now for me. Okay, I hope you get it, guys. Okay, so that's how we can add a default origin. If user is missing their origin, it will automatically take the default origin. Okay, you can change this origin as per your requirement. If you're in, let's say, Thailand, you can give Thailand. If you're in, let's say, USA, you can give USA. Okay, it's up to you. So yes, this is how we have to add all of the API key. Now let's collect the grok API key first of all. So what I will do, I'll just go to the grok platform. So you can search for grok API key. Okay, simply search for grok API key and go to the first website. and you can create a API key here. Okay, so let's create a API key. So what I can do, I can maybe remove my previous API key. I'll create a new one. I'll give the name. Let's say I'll give my TripMate agent. TripMate. No expiration. Just try to keep it here. If you want expiration, you can also select. Now let's submit. Now this is your API key. Just try to copy and make sure you are adding inside your environment variable. Okay. Yep. Now you can ask me, I have given double quotation here, but in the database URL, I haven't given a document double quotation. See, whenever you are adding the database URL, no need to give any double quotation. Okay. Because database URL is a sensitive information. If you are give quotation, sometimes it will also consider as a quotation as this URL. Okay, so that's why I'm not giving any kinds of quotation. Perfect. So we have successfully copied the Grok API key, and inside Grok, you will be able to see different models are available. Let me show you. If I go to the dashboard, I think playground, and here you have different model. So here I'll be using Meta Llama model. Okay. You can also use any other model. It's completely up to you. Then the next thing, guys, I need my aviation stack API key. Okay. So let's search for aviation stack API key. You can simply search on Google aviation stack API key. So this is the first website. Just go to the website. Okay. So this is the website, guys. Now here you will see one option, get free API key. But for this, you have to sign up. Okay. Sign up in their account. So I already have the account. I'll just try to log in. Let's give my email and password and log in. Okay. So I've logged in. Now here you have the API key. Okay. Just try to copy this API key. This is the API key, as you can see. Just try to copy and you paste it here. Okay, this is my aviation stack API key. So we need this aviation stack API key to get the real-time flight information. Okay. So as you can see, this is the interface. So free real-time flight status and global aviation data API. Okay, this provides flight tracker, airport timetable, data web service trusted by 5,000 plus of smartest company. Okay, fine. Now the next thing I need, which is Tably API key. Okay, for real-time source operation, I think you saw the diagram, right? So I have already collected my aviation stack API key and Grok API key. Okay, for the large language model provider. Now for real-time source operation, I need Tably API key. Now let's collect this Tably API key. So for this on Google, just try to search for Tably API key. Go to the Tably and make sure you log in with your account. Okay, now here you have the API key. Okay, so previously I already have some API key. Maybe I can collect, or maybe I can create a new one. So let me delete some of the API key. I'll create a new one. I'm going to name it as, let's say, my project name. Now simply create the API key. Okay, now copy this one and add inside your environment variable. Now, last thing I need my LangSmith API key for the tracing. So we'll be using LangSmith platform. So you can search for smith.langchain.com. So this is the LangSmith platform. So if you don't have an account, guys, please try to create one account. So I already logged in with my account. Okay, but for you, it will look like that. Okay. So once you have done that, you have to collect the API key. So left hand side, you will see one option called settings. Now here is the API key section. Okay, just create one API key. So I'll create one API key here. You can give the name. Okay, just keep it as it is. Now expiration date, you can give it as never and create the API key. Now copy this API key and mention it here. Okay, and give the name of the LangSmith project. I have given TripMate AI. So it will create this project. Inside that you will perform all the tracing. Okay, so yes, that's how we have collected all of the API key, whichever we need it here. Now what we'll do, guys, we'll just try to define the folder structure. Then we'll try to implement the component one by one. So guys, now let's try to define our folder structure. So first of all here, what I'm going to do, I'm going to create a folder. I'm going to name it as tools. So inside that, I'm going to create all of my tools I need for this development. So I think I need some tools like these aviation stack tools. So this function I'll be writing separately, so it will get the real-time flight informations. Then for hotel agents, I need Tably, right? So Tably will do the real-time search operation. It will get the different information, latent information. For this I will be creating another function. Okay, so that's how I need separate tools, and this thing I will try to define inside my tools. So let's create some file inside that. So first of all, I'm going to define a constructor underscore init underscore dot py. Now inside that, let's create a file. I'm going to name it as flight tool dot py, and I'm going to create another file. I'm going to name it as Tably tool. Tool.py. Okay, yeah. Now I need another files here. I'm going to name it as backend .py. Then I'm going to create another file called app.py. So this is going to be my endpoint. Okay, and I'm going to create another folder called templates. So inside that, I'll try to write my front end codes. That means HTML codes, right? Templates. Inside that, I'm going to create a file called index.html. So here we'll try to write all of the HTML code, because I told you we'll be using HTML, CSS, JavaScript with the Fast API, and Fast API needs this template folder and this is HTML file, and whatever CSS and JavaScript file I'll be writing, it should be available inside static folder. Okay, static folder. Inside that, I'm going to create two more files. One is style.css, another is script.js. Okay, and if you don't know about HTML, CSS, JavaScript, no need to worry. Simply you can take the help from ChatGPT and you can create this at the user interface for you. Okay, so yes, these are my folders and file I need for this development. Now let me close this at the tab one by one. Now let me commit the changes on my GitHub. So simply I'll tell folder structure edit. Now if I go to my GitHub, refresh, see all of the folder structures are available. Okay, so later on I also need Docker file. I will use that whenever I'll do the deployment. Okay, as of now it's completely fine. Now first of all, what I can do, guys, first of all, let's say here I'm going to define the tool. Okay, first of all, let's write this Tably tool. So I already installed the environment, and the environment name is travel, right? I think I created travel. I'll select this environment. Okay, now let's import some necessary package. I'll import Tably, import Tably client. Okay, then I need operating system, then I need .env. So from dot env import load env. Done. Now I'll try to load my environment variable. Then let's create a Tably client first of all. So client is equal to Tably client. So first of all, inside that you have to pass the API key. So why do you have the API key? API key is available inside my environment. So I'll just write os dot get env. Okay, get env. And what is the name of my key? The key name is Tably API key. I'll copy this and paste it here. So this is going to be going to give me the client. Okay. So after that, here we'll just try to write a function. So def Tably search search. Inside that, it will take a query. That means the search query. Okay. And it will search over the internet. So for this, I'll just try to write response is equal to client dot search. Okay. And inside search, I'll give my query. Query is equal to my query. And there is another parameter you have to give called max result. Okay. That means how many maximum search result you want. So I need 5 results. Okay. 5 search results I need. Done. Then whatever results I'll try to get, guys, I'll just try to do some refinement operation. That means it will also give me some kinds of metadata, but I don't need the metadata. I only need the content, right? And to filter out, I have written this code. Let me show you. First of all, let's define the result. So it is going to be an empty list. Okay. So this is the filter code I have written. So it will run a for loop. Okay. So it will run the for loop on the response result, and it will get the title URL snippet. Snippet means the content, and it will length the snippet. If the snippet it is more than 300 words, so what I'm going to do, I'm going to split it, and I'm going to append in my result list. Okay, that means I'm only taking the content from my search result instead of some metadata. Okay, so yeah, I think it's done. Even you can also remove this if you don't want. So this thing I have added just to keep only the first 300 character to avoid wall of text. Okay, so that's why. But if you want, you can take the entire snippet if you want. Okay, it's up to you. Because we are using a free large language model, and definitely some input output limitations are there, token limitation is there. So that's why I've taken like some like important fast character instead of the last one. But you can ignore this line. Okay, maybe you can directly take the snippet and you can add inside the results. Okay, this is completely up to you. So this is my Tably search function. Okay, now let's test whether it's working or not. So what I can do, maybe I can create another file here. I'm going to name it as test.py. Let's import this from tools.tably import Tably search. Now let's define an object. I'm going to call the Tably search. Inside that, I'm going to give a query. So let's say I'll give best hotels in India, and I'm going to print the response. Now let's execute. So Python test.py. So you can see this is the information we are getting. Best hotels in India. So it is see, it is referring different website, real-time website. Okay, that means tripadvisor.com, and it is finding some best website hotels. Okay, then some other YouTube resources also it has referred, some review it has seen, right? And it is giving you some best hotels in India. Okay, so that's how we are getting best out of all of the let's say resources out there with the help of this tably instead of manually exploring. I have the tably, I can search like I need best things. It will automatically search over different website hotels, okay, and it will give me those information, okay, for my agents. This is the idea. See, okay, it is referring that URL. That means this function is working completely fine. There is no issue with this function. Now simply I'll just try to open up my code again. Yeah. Now next guys, I'll be writing my flight tools. Okay, this tools I have to write. Now this will give you the real-time flight informations. Okay, so for this, let's import some necessary library. So I need operating system. I need regular expression. I need certify. I need airports data. I need py country. Then I need .env. So from .env import load env. Okay. Then I'll load the environment variable. After that, see, if you're using Windows operating system, you might get a path issue. So to prevent that, we add this two line SSL cert files and request key bundles. Okay, you have to give certified.wire. So if you're getting the path issue, that time you can give. Okay, so I have given for the safest purpose. Then first of all, I have to get my aviation API key. So I'll just write API underscore key is equal to os dot get env. Okay, and what is the name of that? And the name of that is aviation API key, aviation stack API key. I'll just try to get this API key. So once you get the API key, you also need to take the origin. See, I'm taking the origin as well. Default origin, we mentioned Dhaka here, but if you want, you can also change it as per your requirement. Okay, so here my default origin is Dhaka. If user is not giving any default origin, it will take the Dhaka. Otherwise, it will take the default. It will take the origin. Okay, from the user query. Then what is the base URL for aviation flights? So this is the base URL. You can visit the base URL. So here you have to give a API key. If you give the API key, this will return you the aviation. Sorry, this will return you the flight information. Okay, so we are hitting this website API. Okay, now first of all, I will load the airports data. So to load the airports data, you have to use airports data.load. Then you have to give IATA. Okay, so it will give you all the airports. Then I will also mention my country alias, because sometimes user may pass the alias information, right? Let's say user will give US. US means USA. Okay, that's how it has all the alias name for all the country. Let's say Korea, KR, Dhaka, DAK, right? I already told you. So this is called alias. So we are defining the alias. Then country main airport. So all the country main airport, I'll just try to mention here. So these are the airport name. Okay, so BD Dhaka, India, Delhi, like that. Then city main airport. These are my city main airports. Okay, we are defining. Then we'll just write a function for cleaning the text. So clean text. So this will take the text and it will perform the cleaning operation. It will remove some stop words and all. Okay, and it will return you that. Then I'll write another function. This will return you country name to code. Okay, if you give any text, so that means the country name, it will return you the country code. Then airports country matches. So if you're giving if you're giving any airports and country code, it will give you the airports. Okay, then get best airports for the country. For this I have written another function. Okay, so get best airport for the country. So you just need to give the country code, it will give you the best airport for that. Then some other things I have also added here. So this is like more robust code I have written. um, if you see over the internet, right, and if you see this aviation stack API key code, you will see different codes are available over the internet. People are using to get the real-time information, real-time flight information with respect to all the country. Okay, so I utilized the internet resources and I prepared the entire functionality for you. Okay, so this is giving you the location. Okay, then let me show you some other things I have added. So this is the entire code, guys. Okay, so one thing I had to import, which is request. Now see, this is the entire code I have written to get the flight informations. Okay, so see, these are some dependency utility function I need to get the airport informations, flight informations. See, and some of the functionality I generated from ChatGPT just to make it more robust. See here, my main intention is to handle all of the country user is giving, right? So that's why these are the things are required. So see, it will return these are the thing: airlines, flight status, departure, okay, terminal gate, schedule. So these are the information it will return from the aviation stack API. So search flight. See, we are getting these are the informations. Okay, now let's test this whether it is working or not. So what I can do, so this is the function search flight. This is my final function. This takes the query and the limit. So by default limit I have given 10. Okay, 10 information it will give you. Okay, 10 flight information it will return you. So let's test it. So what I can do, maybe I can copy this code. I'll go to the test. I'll comment this. Let's import that. So from tools dot flight tools import search flights. Okay, now let's mention the search flight and I'll get the result and I'll print that. Let's say I'll give Nepal, trip from Bangladesh. Now if I execute, now see, this is giving you all the flight information from Bangladesh to Nepal. See, all the flight information it is returning you. Okay, and why this is happening? Because I have written this code. Okay, this is like more robust code and it can handle almost all kinds of country. Okay, all kinds of flight informations. Okay, so I took the help from ChatGPT. I prepared this entire functionality for you. Even we can also write a small function, but a small function has some limitation. Only if you hit the aviation stack API key, that time sometimes if you are giving the wrong, let's say, location name, that times it will return you none. Okay, so to handle this kinds of scenario, because user can give anything, right, in the chat interface, they can sometimes let's say give the wrong input, okay, of the country. That time it can also handle this kinds of scenario. Okay, that's why I have written this code. Now you can ask me why I'm not using tools decorator here whenever I'm writing the tools. See here, I'm not going to use it as a like custom tool. Instead of that, I'll be using it inside my agent. Okay, I'll tell you this part how to do that. That's why I'm not using any kinds of tool functionality from LangChain. Okay, I'll tell you. So yes, my Tably and flight tools functionality is added and this is completely working fine. We have already tested. Now we'll start the agent workflow. Okay, but before that, let me commit the changes. So here I'll just write flight and Tably tools added. Now go to GitHub, refresh. This is available. Okay. All right. Now let's work on the agentic workflow part. That means right now my tools are ready. Okay. All the tools, whatever we'll be using, aviation stack and Tably, these are ready. Okay. Then now I'll be working on the agent part. Okay. We'll try to define all the agents one by one, and we'll be creating the LangGraph workflow. Once all of the agent implementation is complete, then we'll also define the state. Okay. And this state will try to save inside my Postgres SQL database. Okay. So yeah, this is the entire plan. Now let's try to work on the agent workflow. For this, I'm going to open up my backend.py. And here I'll just try to write all of my code. So first of all, here, let's import all the necessary library. I need operating system. Again, I need certify just to prevent that path issue. And I need .env as well. Load env. Okay. So I'll load my environment variable. And this is the code I need to prevent that path issue. Okay. Then I need some other libraries as well. Let me show you. These are the libraries I need. So I need this typing, type dict, annotated. And why I need, I think you know, to define the state, okay, of the graph. Then operator I need, because here we'll be using the reducer concept, because all of the conversation we are doing, right? Let's say I'm giving an input, my agent is giving an output, right? And this output I don't want to replace with the previous one. I have to add it like a list. Okay. And for this I can use reducer concept. Okay. I think you know, we have already studied about this thing inside our course, right? Inside my Agentic AI course, I already told you about that. If you haven't checked that, please try to check. Then UI ID I need just to define a session thread. I think you know, in persistence memory we have to give a thread, right? Thread ID. So every times we can generate new threads, okay, for the user. Then this is for the Postgres, okay, database. Then we are also importing this row, dict row, okay, for the Postgres database. Then from LangGraph we are importing state graph, start and end. And this is the checkpointer. So from LangGraph checkpoint Postgres, we're importing Postgres saver. Okay, so we'll try to save my checkpoint in my Postgres saver. Apart from that, I also need to import, these are the libraries, like from LangChain messages, I need any message, human message, AI message, system message. Then from Grok, LangChain Grok, I need chat Grok, because we are using Grok API provider to access the large language model. And the tools we have created, so from tools dot Tably, I'll import my Tably source, and from tools dot flight tools, I'll import the source flight. Okay, these two things I'll try to import. Okay, so yeah, these are my imports I need as of now. Now, first of all, here what I'm going to do, I'm going to define a function. Okay, so this function, what it returns the database URL. That means, I think you remember, let me show you. So let me close, these are the files. So I think you remember in the .env we have mentioned the database URL. Okay, so this is the database URL. So this database URL I have to return, okay, just to connect with my Postgres SQL database server. Okay, so for this I'll define a function. So see, this is the function. Only you just need to do a slight modification here, which is that at the last, okay, at the last of this URL, you will be adding this SSL mode is equal to required. That means if this is your database, right? So here we are adding this line. We are adding this line. We are adding this thing, okay, at the last. This thing at the last we'll be adding. Okay, this is required. Why this is required? Because here we will be connecting with my remote Postgres server, right? And for remote Postgres server, this is required. So that's why we are checking. First of all, we are getting the database URL. Then we are checking if not database URL, I'll raise the exception. Database URL is missing. Otherwise, I'll try to check if SSL mode not in database URL. I'll just try to add it and return the database URL. Okay. Now how this will look like. So let me show you. So maybe I can call this function. So URL is equal to database URL. So I'll print the URL right now. So I'm here, Python app.py. Okay, sorry, it's backend.py, sorry, my mistake. So Python backend.py. Now see, this is what we are getting. This is the entire URL. At the last, see, it is adding this thing. Okay, it will give you this question mark. Then this SSL mode is equal to required. Okay, this thing it should add. Then I will be able to connect with my Postgres remote server. Okay, which is running on Red Hat. Okay, I hope you get it. That's why we are giving this function. Yeah. So now let's delete this code. It's not required. Okay. Now guys, we'll try to get some other things like my let me show you. Like my Grok API key. So we are loading the Grok API key. Okay, from the environment variable. Then here we'll just try to write a condition. If not Grok API key found, it will raise an exception. Okay. Now we'll try to define the large language model. So here we are defining the large language model. As you can see, we are using chat grok, and model is equal to, I'm using llama 3.37 billion versatile model. Okay, this is available on the grok. See this one. Okay, this model we are using. Okay, now you can use any model, only you just need to give the model ID. Okay, just try to check here. It has the model ID. Just copy this model ID and paste it here. It will use that model, and we are giving the API key. Then we have to define the state. Okay, my graph state. So this is the state I have prepared, guys. And I think you know what is state and how to define the state. Each and everything I have completed in my course. Please try to check, guys. Okay. So I named it as stable state and inherited with the type dict. First of all, the message. That means you can match with here. Message. Okay. Whatever message user is giving, I'll try to store here. But this should be reducer object. Okay. That means we are doing operation.add. That means every time it will add that message. Okay. Instead of replacing. Then user query. Whatever query user is passing, I'll try to save in the user query. Then flight result, hotel result, then itinerary result, and one additional things I have provided here, which is LLM calls. That means I want to see how many times LLM calls we are doing here. That means we'll do the LLM count as well. This thing I also stored inside my state memory. Okay, that is my shared memory. Now, first of all, I'll define my flight agent. Okay, the fast agent. Let's define the fast agent. So this is my fast agent, flight agent. Okay, so I named it as a flight agent. It will take this state, okay, as a shared memory. Then first of all, I'm taking the user query from this state, and we are doing the flight search operation with the help of this search flight function we have written inside my flight tools. Okay, that is why I'm not using this function as a tool, custom tool. Instead of that, I'm using inside my agent. Okay, I think you remember, I think you get it, right? So why I'm not using custom function. Yeah, so I'm using directly inside my agent. So it is doing the search operation. It will get the flight information, and I'm returning the flight information as a result and AI message. Okay, the flight result fetched. Then I'm also doing the LLM count. That means initially my LLM call should be 0. Okay, so I'm just getting that particular data, and I'm doing the +1 add operation. That means if initially it was 0, it will add the +1. That means 1 LLM call I have done. That's how many time LLM call I'll try to do. I'll just try to update this LLM calls. Okay, done. So this is my fast agent we have prepared. Now let me define the second agent, which is nothing but hotel agent. Okay, now let's define the hotel agent. Now what hotel agent do? It will use the tably search, and it will get the hotel informations. See, this is my next agent, which is hotel agent. So again, it will take the state, and this is the query, best hotels for user query. That means if user is giving, let's say, I want to visit Japan from Bangladesh. So Japan based hotel it will try to find, right? And for this we're using tably search functionality. So this is the tably search functionality. It will found best hotels, okay, from the internet, and it will return it here. Then I'm returning this hotel result as well as the AI message hotel information fetched. And again we are updating the LLM calls with +1. Okay, I think you get it. So this is my second agent. Now I'll try to define my third agent, which is itinerary agent. Okay, so basically this will do the plan. It will basically create the places to visit, activities, all of this thing, right? So here what I'm going to do, I'm going to utilize the large language model here, because without large language model I can't generate the plan, right? So that's why I have to use the large language model. So this is my next agent. Okay, inside backend.py I have to write, this is my itinerary agent. Okay, as you can see, itinerary agents, this is taking the state, and this is the prompt I am defining. So create a complete travel itinerary, user query, this is the user query, this is the flight result, this is the hotel information. Okay, make the itinerary practical, budget hour, and easy to follow. Okay, now here we are invoking the LLM. The LLM we have defined, I think, remember, this is the LLM. We are invoking the LLM with this prompt. We are giving the system message, you are expert travel planner, and this is the human message we are giving as a prompt. Okay, then after that we are returning the itinerary response message as well as the LLM call we are also updating. Okay, I hope you get it. So that's how we are completing the third agent, which is itinerary agents. Now we'll be creating the final agents, which is final response agents. That means it will take all of the results and it will combine everything and it will generate a final response for me. Okay, so let's try to write it here. So this is the agent for final response. So this is our final agent. It will take this state again, and this is the final prompt. Generate a final travel response for the user. This is the user query, flight information, hotel information, and this is the itinerary plan. Format the final answer beautifully using these sections. That means it will have the trip summary, flight information, hotel suggestion, day by day itinerary, estimated budget, final recommendation, and some important note as well. Okay, so yeah, this is my entire prompt, and we are again invoking the LLM. We are giving the system message, you are a professional AI travel booking assistant, and this is the human prompt we are giving, and whatever response I'm getting, I'm returning as a response, and I'm updating my LLM call. Okay, that's how we have completed 4 agents implementation. Okay, now we'll try to build the graph. So in LangGraph we have to define the graph. Let's try to define the graph right now. So we'll build the graph. So to build the graph, first of all, I have defined my state graph. I passed my state, and this is going to be my graph. Now we'll try to add all of the nodes one by one. First of all, I will add my flight agent, then hotel agent, then itinerary agent, then final response agents. All the agents I'll try to add one by one. So these are my agents. Okay, I'm adding the nodes: flight agent, hotel agent, itinerary agent, itinerary agents, flight agents, sorry, final agent, final agents. I have added all of the agent node. Now I have to do the edge connection. Okay, that means flight agents would be connected to the hotel agent would be connected to the itinerary agents would be connected to the final response agents. Okay, that is the connection we have to build right now. So let me show you the connection. So this is the connection. So you can see start to flight agents. Okay, then flight agents to hotel agents, flight agent to hotel agents, then hotel agents to itinerary agents, hotel agents to itinerary agents. Okay, then itinerary agents to final response agent, to final response agents, and final response agents to end. Okay, so this is the connection we have done. Now we have to define the Postgres checkpointer. So I think you remember we already written a function called database URL. So basically this returns the database URL. Okay, and we are storing the URL inside a variable called database URL. Now I'll try to do the connection. So we are using psy copg.connect. We are giving the database URL. Then auto commit is equal to true and row factory is equal to dict row. Okay, these are the parameters you have to pass, and it will give you the connection. And this connection I have to pass inside my checkpointer. So Postgres server, I think remember we imported from checkpointer here, from LangGraph checkpointer Postgres server. Inside that we have to pass this connection, and this will return to the checkpoint, and I have to do the checkpointer setup. Once it is done, then I'll try to pass this check pointer inside my graph. Okay, we'll try to compile. So travel graph is equal to graph dot compile, and we are giving the check pointer. Now all of this state would be saved inside my memory. Okay. Then once everything is done, now let me write the function for my fast API. So this is the function, final function. So run travel agent. So this takes the run user input and the trade ID. Okay. So first of all, if user is not given trade ID, so what I'm doing, I'm just generating a unique trade ID, and we are preparing the configuration. Okay, configurable inside trade ID. I'm passing my trade ID. Then I'm invoking my travel graph. Okay, so here we're doing the invoking. So we're giving the human message user input, and initially my flight result, hotel result, itinerary, LLM cost would be empty. That's why I'm passing as a empty. Then I'm passing the configuration. Whatever result I'm getting, I'm just checking the content and I'm returning the response. That is my trade ID, answer, flight result, hotel result, itinerary, LM cost. Each and everything I'm just returning on my front end. Okay. And from here, I'll try to get the informations, and what I will do, I'll just try to show in my front end. Okay, the front end will try to create. Now let me test whether it's working or not. So what I can do, I can maybe run this travel agent test. I'll copy this and open my test.py. Let me import here. So from backend, import run travel agent. Okay, and then again I'll try to comment out. So response is equal to run travel agent, and I'll print the response. Even maybe what I can do, I can, instead of writing like that, I can write a for loop. Okay, let me show you. I can write a for loop like that. So here I'm taking a user input from the user, and okay, instead of for loop, maybe I can directly run. Okay, then I'm running the travel agent, this function, and I'm passing the user input and trade ID. Just for testing purpose, I've given test user, and whatever response I'm getting, I'm just printing the response. Okay, now let me test. So I'll just try to execute. So I'll just run Python backend.py, not backend.py, sorry. It should be test.py. Okay, let's execute. So Python test.py. Now it is asking the user input. So let's give an input. So this is my user input. Plan a complete 7 days India trip from Bangladesh, including flights, hotel, sightseeing, 102 lakhs. Now let's see. Now see, this is the entire plan I'm getting. So final response, the summary, flight information, hotel suggestions, day by day itinerary, then estimated budget, final recommendation. Amazing. Okay, it's working fine. Now we have to add this inside my user interface. Okay, right now my backend is ready. Okay, we are able to test it perfectly. Now we'll be creating the front end user interface with the help of fast API, and we'll be writing the fast API route. Okay, backend route, and so that my front end can communicate with my like backend. Okay, so for this we'll be using fast API service, and fast API is a production grade web framework. Okay, especially API creation framework you can use. Okay, so let's try to implement my fast API code, guys, right now. And one more thing I want to show you, I already executed my workflow, and it has executed successfully. I think we have seen that. Now let me see whether it is able to store the checkpoint in my database or not. Now I'll open up my pgadmin, and now if I refresh on my table, right? Now if I go inside the table, you will see that all of the checkpoint has created. Okay, now here is a checkpointer table is there. Now just try to right click, and there is an option called view edit data. Now just click on all rows. Okay, if you do that, you'll be able to see that all of the checkpoint is saved here. See, all of the checkpoint it has saved. Okay, this is the state memory, and it has also traced on my LangSmith platform. Let me open my LangSmith. Done. If I go to my LangSmith, so tripmate AI, if I go inside that, now see, this is the LangSmith execution. Even you can see the trade wise. Okay, the test user trade we have given initially, and this is the execution. Okay, this is the execution it has done. Okay, see, amazing, right? Now let's try to add my fast API code. So for this, I'll open up my app.py, and here let's define all of the code. And I'm expecting, guys, you are already familiar with fast API here. Fast API knowledge is required. So here, what I'm going to do, I'm going to import some necessary libraries. Yeah, so I'm importing path from pathlib, traceback, uvicon. From fast API, I'm importing fast API request, fast API, I'm importing HTML response, JSON response, static file, Jinja templates, and base model from Pydantic. So here I need Pydantic just to define my data structure. I think I already completed Pydantic videos as well on my Agentic AI course, and why Pydantic is required I already told you. Please guys to go through that session. Then I need another functionality, which is my this function, run travel agent from my backend. Let me import it as well. So from backend, import run travel agent. Okay, first of all, let's create a base directory. Then I'll define my fast API app. That's how we can define the fast API app. So I've named it as AI travel planning system, or maybe I can give this name, tripmate AI. Okay, tripmate AI. So this is a LangGraph multi-agent travel planner with fast API frontend. And this is the version we have given. Okay, now first of all, you have to mount your static folder as well as the template folder. So let's mount. So because inside static you have JavaScript and CSS, and template you have the HTML. So we are doing the app.mount static, and this is my static folder file directories. Okay, we are giving it, and similar wise we have to give the templates as well. So you can see Jinja templates, I am passing my directory which is templates. Inside that I have my HTML content. Now what I have done, guys, I have already generated HTML CSS code from ChatGPT for this project. See, if you don't know about HTML CSS design, it's completely fine. There would be a separate front-end developer for that. They will be using some other front-end framework like Next.js, React. Okay, with the help of that, they will be creating the front-end server for you, and then they will be connecting with your fast API backend, right? So if you don't know about HTML CSS, completely fine. Just try to go through ChatGPT and just tell I need this kinds of interface. Okay, just give me the HTML, CSS, and JavaScript code. ChatGPT will give you, and you just need to copy paste here, and you need to modify with respect to your requirement. So I've done the same thing. So this is my HTML code I generated from ChatGPT for my user interface, and then I modified, okay, as per my requirement. So here title wise I can give my name tripmate AI. So that's how you can modify the data property with respect to your requirement. Okay, whatever data you have inside HTML content, just try to change. So this is a simple code I have generated from ChatGPT, and it needs a CSS. Okay, just to load the design. So CSS style. So I'll again try to give this CSS design here in my CSS file, static.css style.css file. So this is the CSS code, CSS design. Okay, I have added. Okay, again I generated from ChatGPT. Then just to communicate with my front end just to communicate with my fast API route, I need this script.js. So again, I prepared with the help of ChatGPT. So this is my JavaScript code, and it hits my fast API route. Okay, I'll tell you what are the route it will hit just to get the data. So first of all, it will hit my API travel. Okay, API travel means it will hit that API travel route, and uh, it will get the entire plan. Okay, that means whatever execution I showed you right now, these are the information it will try to get, and it will try to show in my front end. Okay, this is what it is doing. Now let me show you. First of all, let me define all the routes one by one. So first of all, I'll try to define my Pydantic schema travel request. I'm inheriting with the base model, and this has the message and thread ID. Okay, and this is my default route. This is my default route. If you visit my app, first of all, it will launch my HTML page, and this is the final API route. This is my final API route. As you can see, API/travel. If you hit that, and again, I'm using asynchronous. Okay, asynchronous functionality. Why asynchronous? Because it will run my agent is a asynchronous way. Okay, that means parallel execution it will do. I think I already covered this asynchronous as well in my playlist. Just try to go through that. So asynchronous, I'm running. You can see travel planner. It will take the information from the user. That means the user input, whatever user input will pass from the input box. First of all, I'm checking if user is not available. I'm returning message cannot be empty. Then if available, I'm running my run travel agent. That means this function. Okay, this function I have imported from backend. So this function will return what result. Okay, and from the result we're extracting these are the content, and we're returning. Okay, in my front end. And if some exception is occurring, I'm handling the exception. Okay, and some other route I need. Sometimes it will check the health condition of my fast API server. So for this, it will hit this route /health, and it will, if everything is working fine, it will give status is okay, and this is running. And some icon to load some icon. Actually, you need this one. Okay. Now, finally, I'm going to execute my server with the help of uvcon run. So app clone app, because this is app file, and my object is app. My objective app. Okay. Then host and port number and reload is equal to true. So these are the things you have to provide. Okay. Now in this JavaScript, I'm calling this route. If I show you, if I do just Control F and paste, see, this is what actually I'm executing. So whenever user is generating the response, it is hitting here. Okay, and it is getting the information. Let me show you. So I'll execute my app right now. So Python app.py. See, this is running on localhost port number 8000. So I'll come here, search for localhost port number 8000. See, this is your application. Okay. You can see this is your application. Now here you have to give the input. So let's say I'll give this input: Dubai trip, plan a 5 days Dubai trip from Dhaka with flights, hotels, and sightseeings. Now if I click on generate plan, that time it will hit this route. Okay, hit this route, and it will get all of these information. It will generate all of the information, then it will get and show in the front end. Let me show you. See. Okay, it is terminating. Okay, because my previous application is running. Okay, I already executed my this app previously just to show you. So let me first of all stop this execution. Okay, now it will run. Okay, it's running. Now refresh again. Now let me give this prompt and generate the plan. Now see, this is the entire plan we are getting. Okay, in a beautiful format. Okay, and there is a download PDF button. And how this is coming? Because of the front end design we have done. Okay, so this work is completely responsible for front end designer. So you just tell them, okay, what you need. So if you need this kinds of download PDF, or if you need let's say any download any markdown file, you just tell them. Okay, they will try to prepare for you, and um, you can just use that as it is. Okay, and this is the thread it has created. Okay, because we haven't passed any threads, that's why it has created a randomly generated threads. Okay, so that's how we can give any kinds of prompt right now. Let's say instead of Dubai, I'll give maybe Thailand. See, this is the plan for the Thailand. So this is the summary, this is the flight information, this is the hotel suggestions, this is the day by day itinerary, first day, second day, third day, fourth day, fifth day, sixth day, 7 days, okay, an estimated budget you need, then final recommendation. Okay, amazing, right? Now I can easily download this file and I can store in my mobile phone, okay, and I can use it anytime. So yes guys, that's how we can implement this entire system. And if I show you my checkpoint right now, if I again do, let's say, refresh, see, all of the checkpoint would be available, all of the conversation memory would be available inside my Postgres. See, okay, now see, initially I executed test user, now this is the current user, the current thread, okay, current thread execution, and these are my messages. Now you can also see the Langsmith. So if I go to the Langsmith, if I again refresh, now another thread should be created. See, this is the thread and 2 conversation I have done. Now this is the 2 conversation. Now you can see all of the informations, okay, which tools it is using, each and everything is visible here, input and output, each and everything. Okay, so amazing guys, we have successfully completed our implementation and it is working fine. Now what I want to do guys, I want to deploy it over the render cloud. Okay, so I'll deploy this project on my render cloud, but before that let me commit the changes. So here I'll just try to app edit, commit, and see the changes. Okay, now if I go to my GitHub, refresh, now see, it's updated. Okay, now it's ready for the deployment. Now let's do the deployment of this application. Okay, so guys, for the deployment, we'll be using Docker. So let's create a file here. I'm going to name it as Docker file. And inside that, you have to mention all of the Docker related command. And if you don't know about Docker, guys, Docker is a containerization service. And this tutorial is already available on my YouTube channel. Let me show you. So if I go to my YouTube, right, DSwithBappy. So if you go to the video section, I already have a full MLOps course. Okay, here, if you see here, this is the MLOps course. You can open it up. And this course already covered the Docker. Okay. Yeah, so see, Docker for MLOps. You can at least go through this Docker part, okay, and try to master the Docker. And if you're interested learning entire MLOps, this is already available. This is around 12 hours of recording. You can go through that, okay. And if you like the content, please try to subscribe to my channel. So Docker is required. I'm expecting you already familiar with Docker. So simply I'll try to add all of the Docker related command here. So these are my Docker related command, guys. As you can see, first of all, I'm taking a beige image 3.11, creating a working directory, adding some environment variable, then running some commands, copying the requirement.txt file, then installing the requirement.txt file, copying all of my source code. Then this thing I don't need. I'll just try to remove. This thing I not did. Then I have to expose the port. Okay, port should be port number 8000, I think, right? We are using port number 8000, so I'll try to add port number 8000 here. And we are running the command uvicorn app file, localhost, and port number 8000. So this is my Docker file. Okay, I need, and for this I need to create another file which is .docker ignore, and here you have to mention all of the files and folder you want to ignore during Dockerization. So these are the thing I'll try to ignore, okay, during Dockerization. So now let me push the changes again, and what I'm going to do, I'm going to also update the readme file. Okay, I already created the readme file update. So I have added a beautiful readme content. Let me show you. So this is the readme, guys, I have added. So I have given the entire project summary, features, tech stack, project structure, prerequisite, environment, installation, running the app, endpoint. Okay, so each and everything I have added. So your project should have one beautiful readme file, guys. Okay, this is super important. So readme, just try to add. One more thing I want to add, which is I will give my project name as it is. Now it looks good, I think. Now it looks good. So yeah, I think we are done. Now let me commit the changes. Docker, edit. Now if I go to my GitHub, refresh. Now see, beautifully I have added the readme and each and everything. Okay, now it is ready for the deployment. Now what I'm going to do, guys, I'm going to open up my render cloud. Go to the dashboard. Now I'll create a new web service. Okay, select this public git repo and copy this GitHub repo. Okay, copy this URL and paste it here, and let's connect. Okay, see, automatically it has taken, and it is using the Docker services, okay, for the deployment. So everything just keep it as it is, no need to change anything. Simply just create select this free instance. Okay, so I'll select the free instance, but if you're doing like actual deployment, just try to take the subscription. Okay, because free instance has having like very low configuration machine, and there is some limitation as well. Okay, now once everything is fine, you have to add the environment variable. Okay, so what I can do, maybe I can add it from my .env file. So simply I can copy my .env as it is. Okay, and add the variables. Now it has added my grok API key. I can delete this one. Grok API key. This is my grok API key. This is my aviation. This is my default origin. This is my tabeli. This is my database URL. Now this database URL, you have to give the internal database URL. Okay, so again I will go to my render, go to my Postgres server, and go below and copy this internal URL. Okay, this one, copy this. Okay, I'll copy this and add it here. So I've given my internal one. Okay, then LangSmith tracing endpoint, LangSmith API key, and LangSmith project name. Okay, so everything is fine. Now simply deploy the web service. Now it should take some time. First of all, it will build the Docker image. So I will wait, guys. Okay, once this this is complete, this is live, then we'll be able to access that. Now see, it is installing the requirements. See, installation done. Now it is exporting my Docker image as a layer. And if you want to see the AWS deployment, guys, this is already available on my YouTube. On this playlist, you can see AWS CI/CD deployment. Okay, you can go through the CI/CD deployment. You can learn how to deploy as a CI/CD. Even this project also I have deployed as a CI/CD on AWS. Okay, you can refer it. And this is also CI/CD. If you push your changes, uh, it can upgrade your features. Okay, automatically. Again, I created another tutorial like this one, render deployment. You can go through that. So guys, as you can see, our application is live. Now let's copy this URL and paste it here. And if I hit enter, so it should open your application. Now see, our TripMate AI is live right now. Now let's test it. So I'll give this prompt. Okay. 7 days India trip from Bangladesh. Now let's generate the plan. Now it's generating. Let's wait. Now see, this is the entire plan we are getting. Amazing, right? Now it is live. Now you can share this with your friends and family. They can also access that, and you can tell them just use my multi-agent right now just to prepare your trip. So yes guys, this is all about from this implementation. I hope you liked it. So guys, we have successfully implemented our first architecture, that means the part 1 architecture, simple workflow without using MCP, that means model context protocol. Now we'll be working on the part 2, that means the second architecture, and we'll try to integrate the model context protocol here. Before I start implementing this MCP with this project, first of all, I want to give you the idea what is MCP is and how this helps us. If you are adding this MCP in this particular architecture, so what are the benefit you will be getting? First of all, we'll try to understand. Then I'll show you the practical development, how you can integrate the model context protocol inside your existing architecture. That means this architecture now will be developing through the entire session. Okay. So once this is complete, then I'll start with the part 3. So before starting part 3, let's try to understand this part 2. Let's work on the part 2 and we'll try to develop this architecture, okay, step by step. But before that, let's try to understand what is model context protocol is and how it works and how it will help you to build this kinds of multi-agent system here. So guys, as you can see on my computer screen, so this is the definition of MCP. MCP stands for model context protocol. As you can see, MCP stands for model context protocol, okay. It acts like a universal USB port. This is important, just try to remember. It acts like a universal USB port, okay. So I think you know about USB port, right? USB-C port, sorry, USB-C port. So what USB-C port does, basically you can connect this USB-C port with all kinds of device, okay. And there you can connect different other port as well, okay. That means this is a universal port for all the devices. Okay, that's why we call it this MCP as universal USB-C port for the AI application. Okay, especially for the agentic application. Instead of building custom APIs to link an AI model to GitHub, Google Drive, okay, or let's say Aviation Stack API key, Tabili API key, right, or local databases, developer use MCP to create a standardized link. Okay, now what this definition means, let's try to understand. So as you can see here, I have shown you one example. The example name is problem without MCP. Okay. So let's say here we have implemented our agentic AI application. Let's say as of now, we are considering we have implemented this TripMate AI. Let's say this is our TripMate AI app. Okay. We have created the application I showed you, right? And this TripMate AI is using some kinds of tools, right? Some kinds of third-party APIs. Let's say it is using weather APIs. It is also using aviation, okay? Aviation stack API. So with the help of that, what we are getting the flight information, right? Real-time flight information. Then it was using this Tabili as well, okay? Tabili API. So I was using Tabili API, okay? Tabili search tool. I can also name it as search tool, right? Tabili search tool. So with the help of that, I was getting the real-time internet search operation, okay? And just to add some example, I added some other like tool as well. Let's say Google Drive integration, GitHub integration, database integration, then Maps integration, Flight API integration. Okay, I have added these are the information. But as of now, let's try to consider this is our app, TripMate AI app, and it is using some kinds of tool, okay, to perform the task. Let's say whenever user is giving any kinds of plan, right? User is giving any kinds of plan. So what is happening? Based on the plan, it is trying to get the real-time information by using these are the tools. Okay, let's say it will check the real-time weather information in that location. Let's say you want to visit Japan. First of all, it will check the Japan weather condition. Okay, then it will use aviation stack API key to get the real-time flight informations. Tabili for the good hotel informations. Okay, that's how it will get different information. Now, what is happening right now inside our app? So inside our app, these are the functionality I have written as a custom function, right? I have written as a custom function. I have written. And what is the problem with the custom function? Because in the custom function, I was using some kinds of API, right? Some kinds of API endpoint. Let's say if I show you, so I think I can show you, you'll see this thing. See, this is the base URL. Okay, this is a API, right? This is a API I was using from the aviationstack.com. So let's say if I visit this website, I will open this website. Okay, this is the API, right? I will go to the aviationstack.com. So this is the website, right? And this website gives you this API. So where I will get this API? So there is a API documentation. If I visit that, so this is the API documentation, and here they have already written how to use their API key. And as of now, you can see their API version is version 1. Okay, they are using version 1 for this API call, right? So whenever I was using in my code, right, I was using version 1. Okay, so let's say in future, they will change this API to version 2. Let's say they have added some other functionality. They have upgraded something in their API and they have named it as version 2. Let's say like that they have named version 2. Okay, version 2. That time what will happen? So if I'm creating the application with the help of version 1 and after 6 months they have changed it to version 2. So that time what will happen? This API URL will not work. That time if you hit this version 1, it will not provide any kinds of real-time flight information because they have changed it with version 2, right? So to fix that, what I have to do, I have to again come to my code. I have to again open this flight tool, my custom function, and there I have to change this URL. Okay, I have to change this URL and I have to do all of the modification is required to call this URL, right? That means I have to change entire code, right, inside my flight tool. And this is not one time. Let's say after 1 year, they have changed another version and they named it as version 3. That time again, you have to open that. Again, you have to change the code. So that's how there is no possibility your application will remain same. Your application will run as same you have created. Let's say you have created right now and it is completely running fine. Okay, but there is no possibility it will run entire life. So there is a chance this API will get changed. Okay, and you have to open your code and you have to modify this code again and again, right? And if this API changing is happening, okay, frequently, so what will happen? Whenever user is using your application, let's say this is the application user is using, and user will use 24/7, right? 24 hours by 7 days, they will be using your app. So let's say by chance, this API changed, right? This API changed and you are not sure about, let's say this API got changed, right? That time user will come, they will give their plan and they will generate the response, but they will not get any kinds of flight information. Okay, that time this part would be completely empty. So that time user will have a bad experience with your app, right? But you are not sure this API changed, right? Let's say you are not aware about this API has been changed. Let's say after 7 days you got to know, okay, this API got changed and user is getting trouble. You are getting bad feedback from your application. That time you will tell your developer to fix that particular part. But that's how things won't work. Okay, whenever you are creating the application, you have to make sure your application would be robust. If anything is getting changed, right, your application should automatically get to know that and it will automatically fix that. This is called healing. Okay, so your application should heal itself. So you are not responsible to fix your application always. The way you have to create the application, it should heal yourself. If anything is getting changed in the API documentation, instead of manually changing this upgrade, instead of manually changing this migration, your application should automatically fix that part so that user won't be getting any kinds of bad experience. Okay, so that's why MCP comes into picture. Okay, that's why MCP comes into picture. So right now, the way I have created this application, it is directly connected with these kinds of API tools, right? If this API tool is getting changed anytime, let's say it is getting version 3, that time definitely this function is not going to work. Okay, that time you will be getting no data here, no data. And if you're getting no data, user will have a bad experience with your app. Okay, but if you are continuously monitoring your application, if you're changing these are the documentation, let's say regular basis, whether they have changed or not, that time it's completely fine. You can still use this application, you can still run this application, there is no issue with that. But let's say in an application you are using thousands of tools, right? Thousands of tools. So is it possible to visit thousands of tool documentation every day and try to check their upgrade, try to check their migration? Definitely not. This would be very hectic for you, and you don't have that much of time to go through all the documentation, right, one by one. So that is why researcher introduced MCP, model context protocol. Okay, model context protocol helps like, let's say, developer to prevent these kinds of problem. Okay, now let's try to see how it will help. But before that, let's try to understand another problem. Okay, another problem user will be having, or let's say developer will be having. Let's say whenever you are creating any kinds of agentic system, let's say here I have created TripMate AI, that multi-agent application, right? So this TripMate AI I have created with the help of this LangGraph framework, LangGraph orchestration framework. So apart from LangGraph orchestration framework, there are some other frameworks are also available in the market, like OpenAI is there. With the help of OpenAI SDK, you can create the agent. With the help of CrewAI also you can create the agent. With the help of Agno you can create the agents. With the help of N8N, right, you can create the agent. With the help of Microsoft AutoGen you can create the agent, right? There are multiple frameworks are available. With the help of that you can create the agents. And every time whenever you are creating the agents, you will be using these kinds of tool, whether you are using flight tools, external weather API tools, any kinds of Google Drive API tools, database tool, it doesn't matter. You will be using some kinds of tool. Okay, and for every framework integration, you have to write this custom function separately. For LangGraph, this custom function would be different. From OpenAI, this custom function would be different. For CrewAI, this custom function would be different. Okay, that means every framework you have to write this custom function as a different. Let's say in future you want to switch from LangGraph to CrewAI. That time what you have to do, you have to change the entire code. The tools you are using, all the tools code you have to change with respect to the CrewAI. That means again this is very hectic task, right? You have to change the entire code base and it will take lots of time. Okay, so why not, I'll just try to make one connection and automatically this change would be happening. So this basically helps us, this MCP, model context protocol. Now let's try to understand how MCP helps us here. So by the diagram itself, I think you can see why I told this MCP as a USB-C port, right? So as you can see, just try to consider this is your USB-C port, right? So USB-C port, what is the benefit of USB-C port? You can connect with any device and you can connect multiple devices here. Okay, that means the connection, okay, the connection would be common for all the devices here. So let's say initially I was using this custom API, right? I was using this custom tools or custom API directly to my application. But right now here I'm using some kinds of MCP server. Okay, so what this MCP server? MCP server is a server. Basically it has the tool you need. Let's say here I have shown you one example of the weather MCP server. So see, for all of the API, right, all of the API you will be using, all of the tool you will be using, for all of the API tools there are some MCP servers are available. Nowadays in internet you can get any kinds of MCP server. For weather information you will be get the MCP server. For Google Drive also you will be get the MCP server. GitHub also MCP servers are available. Database also MCP servers are available, right? From map integration MCP servers are available. Flight integration MCP servers are available. Okay, so for all kinds of tools you have the MCP server. Only what you have to do, you have to use that MCP server. Okay, and this MCP server will automatically connect it to the tool. Okay, the tool it will be using. Let's say to get the weather, what kinds of tool it need get a weather tool, and this tool will be connected to the API, the external API, right? The external API, let's say we are using, let's say as of now I'm considering here I'm using aviation stack API, right? So aviation stack API, what it use, API URL, right? API URL. I think you saw that in aviationstack.com website, there is a URL I was using, right? I was using one URL. So if I'm using this aviation stack MCP server, so it is already connected with that tool, that means the API. Okay, so with the help of API it is fetching the real-time information and it is returning to the agent. Okay, so what it does, basically your MCP server will connect it to the API, and whenever your agent needs any kinds of tool, right, any kinds of information, it will call that MCP server, and MCP server will use that tool and it will give the information, and your agents will try to use that. Okay, that means in future, let's say if your API is getting changed, let's say from version 1 it has changed to version 2, that time it will change here only, right? It will change here only, and automatically MCP will try to heal that. Automatically MCP server will try to fix that. That means this connection won't be changing anymore. This connection won't be changing anymore. Whether you are creating MCP with LangGraph, whether you are creating MCP with OpenAI, whether you are creating AI agents with OpenAI, AI agents with LangGraph, AI agents with CrewAI, it doesn't matter. This connection is not going to change. Okay. So automatically this upgrade, this migration will be updated to the MCP server, because this MCP server we are using some third-party MCP server. We are not creating this MCP server. If there is a way you can create your own MCP server, this is also possible, but most of the time we use third-party MCP server. And third-party MCP server, what is the biggest benefit? If there is any API upgrade, if there is any version update, they will automatically migrate in their server. You don't need to change inside your code. Okay, your application would be connected automatically. Your application will be upgraded to the next update. Okay, so there would be any kinds of downtime. So this is the benefit of using the MCP server. I hope you get it. Now let's go to the next one. Yeah, so let's try to understand this MCP component right now. Okay, but before understanding this MCP component, first of all, I want to clarify one thing. Let's say, and to clarify one thing, let's say I'll draw one simple application diagram. Let's say here we are we have created this TripMate AI agent, right? TripMate AI agent. So this TripMate AI agent is using some kinds of tool, right? It is using aviation stack tool, Tabili tool, right? With the help of tool, it is getting the information and it is using in the agent. But if I'm replacing here with this MCP, let's say instead of this custom tool, if I use the MCP here, okay, let's say here I'm using this aviation MCP server. Okay, aviation MCP server, and this server is connected with the tool, that means the API. Okay, this API, let me show you this API. This is connected to this API. Okay, now what is happening whenever I'm using this this MCP server, and it is continuously using this API, and this API inside this MCP server, it already has the tool, like it has already like this kinds of custom function. Let's say if you want to get the real-time flight information, okay, flight information, so there would be some tool, let's say get flight information, okay, or let's say all flight information. Okay, that's how it will have different tools. So whenever your AI agents will go to the MCP server will return some kinds of tool. Okay, it will return some kinds of tool, and all the tools are connected with this API. Let's say right now the API version is version 1. Okay, so after 6 months, this API got changed with, let's say, version 2. Okay, version 2. So what is the benefit of using the MCP? That time automatically this migration will be happening to the MCP, because this MCP I'm using, this is a third-party MCP. This is available over the internet. This is called remote MCP, right? So this migration will be automatically updated to this MCP, okay, MCP server. So here you don't need to change inside your code. Only you just connected this MCP server with your AI agents. Okay, automatically this upgrade will be available inside your agent also. You don't need to change the code. So the let's say whoever developed this MCP server, this aviation stack MCP server, they will take care of this part. Okay, you don't need to like upgrade inside your code. This is the main benefit here. But in our previous app development, right, inside our previous app development, we are directly connecting this custom function, and if there any upgrade is happening, we have to change it manually. But MCP, here you don't need to change it manually. Automatically server is getting updated and your application is using that particular new upgrade. This is the main benefit here. That's why I have shown this diagram. So this diagram represents that if you're connecting with the MCP server of your any kinds of AI agents we are creating with LangGraph, OpenAI, CrewAI, it doesn't matter. This connection you don't need to change. Whatever upgrade is happening inside the API or whatever inside the tool, it will automatically upgrade to the MCP server, and all of the application will be working on the upgraded part without any kinds of downtime issue. This is the main benefit. I hope you clear. Now to this to run this MCP, right, for this protocol, that is model context protocol MCP uses some component. Okay, so the major component, it has the MCP client and MCP server. So as you can see, let's say we have implemented some agentic application with LangGraph, Crew AI, OpenAI, or Agno, whatever you have created. So all of the agents, right, you are implementing. Let's say here I've created this TripMate AI agents. So this TripMate AI agent should have a MCP client. If you want to use the MCP server, first of all, you have to create a MCP client. So this client is responsible for connecting with the MCP server. That means whatever communication will be happening, let's say you have given a prompt. Let's say I need to plan a trip from Bangladesh to Japan. Now for this, definitely your agent needs to call the flight information. Your agent needs to call the hotel informations with the help of these tools. Now how it will do the communication with the help of this MCP client. So this MCP client will go to the MCP server. It will first of all check how many MCP servers are available, and all of the MCP servers like has the tool or not, all the API integration or not. If it is available, it will automatically understand what kinds of MCP server to use. Let's say here you have given, give me flight information. So for this, definitely aviation stack API should be called. Okay. So let's say here I have listed different MCP server. Let's say travel is there, MCP server is there, weather is there, Google Drive is there, database is there. So let's say if I want to get best hotel information, that time what I have to do, I have to use Travely search. With the help of Travely search, I can search the flight, I can search the best hotels, okay, and I can get the informations. And how this selection is happening, because every agent is using a large language model. I think you know that every agent has a large language model, LLM, right? And LLM has the reasoning power. So whenever you are giving the prompt, I need hotel information or flight information, automatically your LLM is deciding which MCP server needs to be called, and how it is calling with the help of this MCP client. That means MCP client is working as a bridge between your MCP server and your agentic application. That's how whenever you are creating your agentic application, MCP client should be created inside that agentic application. Okay, and this MCP will try to communicate with all the MCP server, whether you want to use any search flight MCP server, whether you want to use any search tool MCP server, search hotel tool MCP server, weather MCP server, Google Drive, database, GitHub, whatever you need. All kinds of servers are available, whether it's remote or whether it's local. You can communicate with the help of this MCP client. That means the major component is MCP client and MCP server, and each of the MCP server is connected with the tool. Okay, different tool. Okay, let's say this travel search MCP server is connected with some external services like flight API, hotel API. This weather MCP server is connected with the weather API. This Google Drive API MCP server is connected with Google Drive API. That means every server having their own API, own tool, right? With the help of this tool, with the help of this API, they're working. Okay, they're working as a tool, right? And if any API upgrade is happening, right? If any API upgrade is happening, so automatically this upgrade is happening inside the MCP server. So that time you don't need to change this connection. You don't need to change this code. This code would be common. Only you just need to connect once, and all of the upgrade, whatever happening in future, it would be available here only. You don't need to change it anytime, right? So this is the main benefit. And to implement this MCP, we have to create this MCP client, and we have to add the MCP server. This is the component. Okay, this is the component of MCP. I hope you get it, guys. Okay, very much clear. Now let's try to see some other things. Yeah, I'll try to show this part right now. So as I told you, this model context protocol is having two components. One is the MCP client, and MCP client should be available inside your agentic application. The agentic application you're creating, let's say we are creating the TripMate AI. Let's say this is our entire TripMate AI application. Okay, inside that your MCP client should be available. So you have to create this MCP client, and to create this MCP client, there is a already a functionality available inside LangChain. With the help of LangChain, you can create this MCP client. Okay, and this client would be connected to different MCP servers. So if you want to use any API, real-time weather informations, or let's say flight informations, you can use the MCP server. If you want to use any database, you can use the MCP server. If you want to access any local file, you can use the MCP server. If you want to use the Google Drive, you can use the MCP server. For GitHub, operating system, internal company system, everywhere this MCP servers is available. Okay, so either you can use the remote MCP server. Okay, I'll tell you about the remote MCP server. Either you can use the local MCP server. Even you can also create your custom MCP server. Okay, everything is possible. Okay, we'll try to see everything one by one. Now, that means in a high level view, your AI application is having the MCP client, and MCP client is connected with different MCP server. So wherever it requires any kinds of MCP server, it will be using that because it has the large language model. And whenever user is giving any kinds of input, based on the input your LLM is understanding, let's say user is asking, tell me the weather in Delhi, right? So your LLM is understanding, okay, it is asking for the weather. Now let's say here you have the list of the MCP server. Let's say you have Google Drive. Okay, you have Google Drive, you have uh, weather MCP server. Now which one to use? User is asking what is the weather in Delhi. So that time your LLM should know, okay, it has to use the weather MCP server. And weather MCP server is connected with different tool like get weather information, get current weather, okay, get humanity, get temperature, this kinds of thing. And automatically your LLM will decide which tool to use. And this tool is connected with API, right? To get the real-time information, weather information, it has to hit a API. So this API connection is already available, right? So that's how the entire system is working. Now let's try to see this thing in a more detailed way. So see, let's say this is your AI app. It has the MCP client, right? And it is connected with some MCP server. Let's say as of now, I have showed you the Google Drive MCP server. Let's say user is asking, uh, upload this file to the Google Drive. So that time it will use the Google Drive MCP server, and Google Drive MCP server has some tool connection. As you can see, these are the tool. So it has find files tool. Let's say in Google Drive we can find the files. In Google Drive we can list folder items. In Google Drive we can read files. In Google Drive we can upload files. In Google Drive we can create any kinds of folder. Okay, these are the tools, let's say Google Drive is having. And what is the purpose of that? For searching file, list content a folder, read a file content, upload file, create folder. Okay, for these are the purpose we use this tool. And this tools is connected to the API of the Google Drive. So with the help of this API call, it is using, right? It is working, right? And if Google Drive is changing their API, let's say from version 1 to version 2, okay, version 2, that time it is changing inside the MCP server. That means this connection you don't need to change. Your application connection will remain same. You don't need to change inside the code. Automatically this upgrade would be happening to the server only, right? So this is the main benefit. That means whenever you are using the MCP, MCP client is going to the MCP server. MCP server is listing all the tools it has, and it is automatically selecting which tool to use. Let's say you want to upload any file. That time instead of using these are the tool, it will only use this upload file tool that time, because user needs to upload any file. Let's say you want to only read the file or download the file. That time this will use this read file tool. Okay, instead of using list folder file items, upload, okay, it will use read file tool that time. Let's say you want to create a folder. So create the folder, this tool should be used, okay, instead of uploading, reading. Okay, these are the things. So that's how the entire MCP works. Okay, I hope you get it. Now see, this thing I have showed you in a more detailed way. Let's say this is your AI Agentic AI app. It has the MCP client inside that, and it has some multiple MCP server. Let's say it has Google Drive MCP server. It has weather MCP server. Okay, and all of the server is connected with different tools. Okay, let's say Google MCP server has their tool for listing files, reading file, creating files, update file, delete file, search file. It has the tool. Okay, and all the tools are using API. I think you know that with the help of API, this is working. For weather also, it has some tool. Like say weather MCP server, it has get current weather, get weather forecast, get air quality, get temperature. And how it is getting this information? With the help of API. It is using some kinds of API. Let's say you have another tool here, another server here, which is aviation stack, so MCP server. And it has also some tool. Let's say get flight information, and how getting the flight information with the help of API. Okay, so I think you are getting right how these things are working. Now every API has their version, like version 1, version 2, right? I already showed you in the documentation. Let's say it is using version 1, it is also using version 1, it is also using version 1. So there is a possibility, definitely this company will change this version, right? If they're doing any major upgrade, let's say it has changed to version 2, that time it's not necessary to change your code inside your AI app, right? Because you have connected with the MCP server, and MCP server is connected with the MCP client. So whatever upgrade will be happening inside the server only. Okay, automatically this upgrade will be happening inside the server, and MCP client will try to get to know that, okay, there is a change has been done. So you don't need to change inside your AI app. That means there should not be any kinds of downtime of your application. User will not any kinds of bad experience, okay? Because continuously your data will be coming up because MCP is handling this kinds of part, right? So that's why we call it as a MCP as a USB-C port, okay? It is once you have connected with the app, you don't need to take care about the other things, okay? Automatically this will take care everything. I hope you get it. So yeah, here I have shown you another example. Let's say this is your AI app, and it has the MCP client and it is connected with multiple MCP server, and every MCP server is using some kinds of tools, right? And all the tools are using some kinds of API call, as you can see, right? So let's say user has given one input. What is the weather in Delhi today? Will it rain tomorrow in Mumbai? Let's say this is the input. Okay. So what is happening? Because your AI app using your agentic app using a large language model, right? And large language model has the reasoning power. So whenever this input will come to the AI app, your LLM will decide which MCP server to use. Okay, whether it has to use the Google Drive MCP server, whether it has to use the weather MCP server. So user is asking about the weather, so definitely it will tell the MCP client to communicate with the weather MCP server. First of all, uh, this MCP client will tell how many server you have. Okay, so this will return, okay, I have Google Drive server, I have weather MCP server. Then MCP client will return that to the LLM. Now LLM will try to tell that, okay, now try to use this weather MCP server. Now again client will go to the weather MCP server and will tell how many tools you have. Okay, so to get the weather information. Now let's say this weather MCP server will return these are the tool. I have get current weather, I have get weather forecast, I have get air quality, I have get temperature. But what is the user question? What is the weather in New Delhi? That time definitely this get current weather tool should be used. Okay, that time all the tools it will return, right? All the tools it will return where? To the MCP client. MCP client will return to the LLM, right? LLM. Now LLM will decide, okay, now it has to use get current weather. Now it will tell the MCP client to use get current weather tool. Now again MCP client will tell MCP server to use get current weather tool to get the real time weather information. Now it will hit that API, right? It has the API connection, right? With the help of API it will get the real time information. Then this real time information will again return to the MCP client. MCP client will return to the LLM. LLM will use that information to generate the final response. That's how the entire communication is working, and this is called model context protocol. The protocol it is happening, right? From client to server, server to client. This is called protocol. I'll tell you this protocol more about that. Okay, so for this protocol it use a method. Okay, I'll tell you about this method. So I think you got to know how this system is working. Okay, fine. Now see, I told you about the protocol, right? So basically your MCP uses this JSON RPC protocol, okay, JSON RPC format to communicate with the MCP server. So let's see if user is asking any kinds of input. First of all, what is happening? LLM is deciding which let's say server to use. MCP client is sending that request. How? With the help of JSON RPC 2.0 message. That means it will have these kinds of JSON, okay, JSON structure. So let's say user is asking about sorry, here this is the let's say input. What is the weather in Delhi today? Will it rain tomorrow in Mumbai? So this, let's say this message would be converted like that. So this is the message. So city name Delhi, and this is a tool call, and it has to get the weather information. So this will go to where? This will go to the weather server, weather MCP server, and whether a server is having some kinds of tool, some kinds of, let's say, tool integration. What kinds of tool? This kinds of tool. So which tool to use? Get weather, current weather. So it will use that tool and it will hit this API. It will get the response. Okay, that means the current weather information, and again it will return to the server, and server how it will try to make the format with the help of this JSON RPC. That means again a JSON file would be created, and there this temperature condition, okay, these are the real-time information would be sent where? To the client again. Okay, and client will send to the LLM. LLM will try to use that, and it will give you the final output. Okay, so that's how with the help of this JSON RPC 2.0 message format, this entire communication is happening. Okay, I hope you clear. Now let's try to see some types of MCP servers are available. I told you there are some types of MCP servers are available. The first one is local MCP server. That means you can create the servers inside your local machine, inside your same computer. While you are running your agent, right? In the same computer, you can create the server. If this server is not available in remote, sometimes this happen, right? Let's say you are creating MCP, you want to use a MCP, right? Let's say you want to access your private folder. Let's say there is a folder inside your computer, you want to access that. So definitely for that, you don't have any remote MCP server. That time you have to create your local MCP server, custom MCP server. Okay, so that time we call it as a local MCP server. So your AI app will use MCP client. So everywhere MCP client would be available. Without MCP client, you won't be able to communicate with the server. Okay, and to communicate with the local server, we use this as STDO communication method. Okay, so this is called actually transport, or means communication method. So to communicate with local MCP server, you will be using this standard IO, input output. Okay, standard input output. The full form of this STDIO is standard input output. This communication method we'll be using. With the help of that, we'll be communicate with our MCP servers. Okay, and there is another one called remote MCP server. So let's say your agentic AI having this MCP client, it is using some kinds of communication method called streamable HTTP. Okay, so all of the internet MCP server are available, like Google Drive, right? This Google Drive, then I showed you some other things, right? Here, Google Drive, weather, okay, database. So these are the actually remote MCP server. Okay, these are the remote MCP server. And to communicate with this remote MCP server, we'll be using a streamable HTTP method. Okay, basically this will be using to communicate with the MCP server. Now, what is local MCP server? You can see a local MCP server runs on the same machine where your AI application is running. So let's say this is your AI application, you have the MCP client and it is communicate with the local MCP server. Let's say you have local file system MCP server, Git MCP server. Okay, let's say Git usually we install inside your local, right? Git MCP server, Postgres SQL MCP server. Let's say we have pgadmin, Postgres SQL we have already installed, right, inside a local machine. If you want to communicate with that, you have to use this MCP server at that time. And all of the communication would be happening with the help of this standard IO. Okay, SDT IO communication. And what is the remote MCP server? As you can see, a remote MCP server runs on another machine on internet. That means, let's say this is your laptop. You have created your Agentic AI application. This has the MCP client. And with the help of internet, you are communicating with some kinds of server. Let's say weather MCP server, Google Drive. Okay, so this is called remote MCP server. You are using some server. It is running on other computer, let's say remote server. Okay, we know that we call it as a remote server. Someone has created this server and it is running and we are communicating with that. This is called remote MCP server. Okay, and the communication we use called streamable HTTP. Okay, then we have another MCP server called custom MCP server. So an MCP server that you create yourself. Let's say you don't want to use local MCP or remote MCP, you want to create your custom MCP server. This is also possible. Let's say you have a secret company database, and to communicate with that from your AI agents, that time either you can't create the local MCP, either you can't create the remote MCP. That time you can create your custom MCP server. Okay, so this is called custom. So the MCP allows you to use local, remote, as well as the custom. Okay, everything you can do, and all of the example we'll try to see inside our practical project. Now let's try to understand what is this STDIO. That means I told you there are some communication type, STDIO and streamable HTTP. So first of all, let's try to understand about the what is STDIO. The full form of this STDIO is standard input, standard output. Let's say you have the application, your Agentic AI application. It is having this MCP client, and the communication it is doing the MCP server. For this, it is using STD, standard output and standard input. So this is only for the local MCP server. This is the way local MCP client and local MCP server communicates. Local MCP client and local MCP server exchange JSON RPC message through a standard in and standard output. Okay. Now there is another one called streamable HTTP. So let's say this is your Agentic AI app. It has the MCP client and it is communicating with this MCP server. That means whatever running on the cloud with the help of the HTTP request. It's obvious, right? If I want to access any other website, I have to use the HTTP communication there because it is running on cloud. That's why it is using HTTP streamable communication type. You can see streamable HTTP is one of the transport mechanism used by MCP client and MCP server to communicate over a network. They exchange JSON RPC message through HTTP request. The message client sends MCP request over HTTP, and streamable HTTP used when the MCP server runs in the cloud. Okay, I hope you clear. Now you can see MCP has the two concepts. That means the message format. The message format I already told you about, the JSON RPC and the transport type. Okay, transport type means this basically this communicates in a two method. One is the standard IO and one is the streamable HTTP. Okay, and everywhere it uses this JSON RPC format. Okay, so yeah, that's how guys the entire MCP works, and this is called the MCP. And if you're using the MCP, what should be the benefit, each and everything I have clarified, okay, from this video. I hope there won't be any kinds of doubt right now why this MCP is required whenever you are implementing these kinds of AI agents, right? And without MCP also we can create the AI agent, but what would be the biggest challenge there, right? To maintain the entire application lifetime. But if you're using MCP, you don't need to take care this thing lifetime. Automatically, this part will be healing itself, right? This is the biggest benefit. And especially in AI agents application, we'll be using tool. Okay, there is no compromise. Tool we have to use. Okay, like as much as tool you will be using inside your AI app, your application would be more powerful. That's why whenever you are using this tool, right, tool concept inside your AI app, that time MCP comes into picture. But if you are not using the tool, that time you don't need to use this MCP. Whenever you are using any third-party tools, use the MCP. Okay, instead of writing the custom function, use the MCP. So this will save your life. Okay, and everywhere nowadays, if you see any agentic application, they're using MCP. Get it? So yes, this is all about from this video, and I have already clarified about the model context protocol. Now there are some MCP servers are available. Let me show you. So if you come to Google and search for all list of all MCP servers, okay, so there are some website, they will show you the all kinds of MCP servers. Okay, see, if you see here, all kinds of MCP servers are available. See, for Brave Search, Everart, GitHub, GitLab, Google Drive, Google Maps, Postgres, okay, Redis. See, all kinds of MCP servers are available. I think some other website is also there. Browse all MCP servers. Here you can see all kinds of MCP servers are available. What kinds of tools and software you have used so far, right? Everything is available. Let's say you want to use let's say MongoDB. I think for MongoDB also it has the MCP server. MongoDB. Just search that. See, MongoDB has the MCP server. If you want to connect with the MongoDB database, it has the MCP server. Let's say you have to communicate with the Google Drive. See, Google Drive MCP server is available. If you want to communicate with the Google Map, if you want to use the Google Map tool, right, inside your Agentic AI, see, Google Map is also there. If you want to communicate with the flight, okay, for flight also, it has different MCP server you can use. Get it? So that's how you can check this MCP market website, and it has all the MCP guideline, how to use that and all. Okay, they have written each and everything. You can refer that. Even they have already given the code how to use their MCP server. Each and everything they have given, you can check that. So I'll show you the practical implementation in my next video. There we'll be creating an end-to-end project with the help of this MCP. There I'll try to show you how we can write the MCP client and how we can connect with the MCP server to implement this application. So what I'm going to do, guys, I'm going to re-implement this same application, okay, the TripMate AI application with the help of MCP. See, this application right now, it is running without MCP. I'm going to actually recreate this same project with MCP, with model context protocol, okay, so that your understanding would be clear. So yes, this is all about it. If you like my content, please try to subscribe to my channel and hit the like. So if you see the architecture of this project, so this is the project architecture, guys. So here I created actually 4 agents. One is the flight agents, then hotel agents, itinerary agents, then final response agents. Okay, and each of the agent was connected with some kinds of tools. Okay, and these tools, guys, I had written custom function. If you have seen that, this is my code. Let me show you. This is my code. So in the tool section, you can see that I have written custom function here. Okay, and what should be the issue with this custom function? This part I have already explained in that model context protocol video. So now, instead of using this kinds of custom function, what I'm going to do, guys, I'm going to use something called model context protocol, MCP. Okay, MCP servers. So this part we'll try to learn, and this is the updated architecture, guys, we'll try to implement in this video. So as you can see, this architecture, this project will try to implement with the help of model context protocol right now. So again, my architecture will remain same, only some slight update I have done. So as you can see, flight agent should be there, hotel agent should be there. One new agent I'll try to add inside this development, which is weather agents. Okay, so basically I want to also know whenever I'm planning for any kinds of trip, let's say I'm planning the trip let's say from Bangladesh to Japan. So I want to know the Japan weather condition. Let's say if I visit Japan, so what would be the weather condition? Should I take my umbrella out there, or should I, let's say, take my sunscreen out there? Okay, so this part I have to know. So how I can get to know? With the help of this weather agents. Okay, weather agents will try to fetch the real-time weather informations and will try to get the informations as well, right? So here again we'll try to use the model context protocol. Then our itinerary agents should be there, then final response agent should be there. And now we can see each of the agents should be connected with the MCP server. Okay, there are local MCP servers are available and remote MCP servers are available. Okay, so both I'm going to show you how we can integrate inside the development. So I'm going to show you how we can add the remote MCP server. Even I'm also going to show you how we can add the local MCP server. Okay, even I'm also going to show you how we can add the custom MCP server. Let's say you don't have any kinds of MCP server, but you want to create your own MCP server. This is also possible. This part I'm going to show you. Okay, so in this single implementation, I'm going to cover up all of the MCP servers. Okay, whatever I have explained in my previous video. That means I'm going to cover my local MCP server, remote MCP servers, as well as the local MCP servers, remote MCP servers, and custom MCP servers. Okay, these three part I'm going to cover. And after that, all of these database integration, I think you remember I also integrated Postgres SQL database. Okay, I already set up this database in my render cloud. As you can see, this database is already running, Postgres SQL. I think you can see it is just behind my screen. Let me show you. See, here is the PostgreSQL server it is running. And this project I'm also tracing in my LangSmith platform. As you can see, TripMate AI. So I was continuously tracing all of the execution, all of the threads. So each and every things you can monitor here. Okay, so yeah, lots of things we had integrated inside this development. So yeah, I'll try to continue with this one. So yes, this is the entire architecture, guys. We'll try to implement inside this video. So make sure you watch till the end. So first of all, let's open up my code. So I'll open up my code. So this is the code. This is my previous project code, the TripMate AI multi-agent system. So here, what I'm going to do, I'm going to just add the MCP, that means model context protocol. So first of all, what I can do, I can create a file here. I'm going to name it as MCP client. Okay, MCP client test.py. Let's create a file. So here, basically, first of all, we'll do some experiment. And once this experiment is working fine, I will try to add inside our final development. Okay, first of all, let's try to see how we can create the MCP client and how we can add the MCP servers there. So if you have already seen my previous video, so there I already told you MCP has two major components. Okay, one is the MCP client and another one is MCP servers. Okay, let me show you. Yeah, so here you can see, so here I already moved all of my Excalibur files. Okay, whatever diagram I have created, it is available inside my Excalibur files folder. Okay, I created this folder and inside that I kept all of this file. And if you want to open it up, you have to use one extension called Excalibur. Okay, inside your VS Code, just try to install. After that, you will be able to open this file. So as you can see, this is the actually components I already discussed in my previous video. That means MCP is having two major components. One is the MCP client and MCP servers. So if you're creating your AI agents application, inside that, first of all, you have to define the MCP client. And in this MCP client, you have to connect this MCP servers. Okay, that means MCP client will try to communicate with the MCP servers and will try to reach this data to the AI agents. Okay, so this is the bridge between your MCP servers and as well as your AI agents. Okay, so first of all, we have to create this MCP client. So for this, we created this file called mcp client.test, mcp client underscore test, and here I'm going to write code related MCP client. But before that, you have to install some of the library. So let me open up my requirement.txt. So this is the requirement.txt. So here I'm going to add some additional library I need for this development. So this three library I need. Okay. So these three library I need. One is the LangChain MCP adapters. So with the help of this LangChain MCP adapters, we create the MCP client. So as you can see, this is the MCP client, right? So to create this MCP client, we'll be using this LangChain MCP adapters. So LangChain has already predefined MCP client. Okay, you can use that and you can define the MCP client. Then you have to use something called nest async IO. Okay, so why this is required? Because already, if you see my app.py, right? If you see my app.py, we are already using this asynchronous programming. Okay, and I told you why this asynchronous programming is required, because here we have created multiple actually route, right? And it's not like that we'll try to wait for another route to be executed, right? So everything should be running in an asynchronous way. That means we are executing in parallel. Okay, and this is required whenever you are creating the AI agents, because AI agents needs so many things to run, right? And if you are running sequentially, so there would be lots of, let's say, time buffering. That means you have to wait for another execution, then your next execution would be happening. So I don't want that. Okay, that's why I'm using asynchronous programming. And this asynchronous programming also I have already taught you in my playlist. Okay, if you can go through that playlist, you'll be able to understand why it is required. So already we are using asynchronous programming inside our fast API development, backend development. But again, whenever I want to implement this MCP, right, model context protocol, it's recommended to use the asynchronous programming. Okay, why? So here you can see why we have to use this asynchronous programming inside MCP. As you can see in MCP, that means model context protocol code, we use asynchronous programming, async await, to prevent long running tasks from freezing the server and blocking the AI agents. Okay, that means MCP servers handle input output heavy operations. Okay, and the standard synchronous code would force the LLM to wait completely idle for one task to finish, okay, before it could do anything else. So using asyncs allows the servers to remain highly responsive and process multiple instruction concurrently. Okay, that means in parallel. So that's why we have to use this asynchronous programming in model context protocol development as well. Okay, so it is super important, guys. If you're not using asynchronous programming, you can't create the MCP client or servers. Okay, this is very much required. You have to use that. So that's why you can see inside my backend development, I was using this asynchronous programming, right, inside fast API. And whenever we'll try to create this MCP client as well and MCP servers, we have to use this asynchronous programming. That means we will be using 2 times, right? So if you are using this asynchronous programming, there would be something called event loops, right, for the asynchronous calls. So now we are using asynchronous into 2 time, right? One is the backend.py, another one is the MCP server development. So there would be nested event loop. Okay, so one event loop would be available inside your backend.py, that means your app.py, right? And another event loop would be available inside your MCP development. Okay, that means 2 event loop would be available, and whenever you want to run the nested event loop, okay, that time you have to use this nest async IO. Okay, this particular package. So this allows us to handle nested event loops. Okay, if you're using, let's say, thousands event loop, it doesn't matter if you're using this particular library. So this will handle this part. Okay, and if you're not using this library, there would be some kinds of error, okay, for the nested event loops. That's why we'll be using this particular library. And the last library I need, which is MCP, that is model context protocol. So if you want to, I already told you I'll be creating our custom like MCP, right? And to create the custom MCP, I will be using this MCP. Okay, MCP library, with the help of MCP library, we can create our custom MCP servers as well. Okay, so that's why I need this. These are the library for this development. Okay, I hope you get it. So for this you have to install that. So let's open up my terminal. Let me stop my application and I'll be installing this requirement.txt. So for this, let's write pip install -r requirement.txt and make sure you activated your environment. Okay, so I think you remember I created this travel environment for this particular project. So I'm installing this library inside my travel environment. So if I now execute this command, see, requirement is already satisfied for me because initially I already installed these are the package. That's why it's available, but for you it will install. Okay, so once you have done that, now we can implement our MCP client as well as we can integrate the MCP servers here. Okay, and we can test whether everything is working or not. If everything is working, we'll just try to integrate inside our development. Okay, first of all, I'm going to show you how we can add the remote MCP servers, and for this I'm going to use actually this one, Tabili. Okay, as you can see, Tabili, we'll try to use this Tabili MCP. This is a remote MCP servers, and if you can search on Google like Tabili MCP servers. Okay, so official Tabili website is having their documentation, Tabili MCP servers. If I open it up, and I already told you almost all kinds of MCP servers are available, whatever you need. So if you want to know more about like how many MCP servers are available, simply just write list of all MCP servers. There is one website called I think this one. This one. So here you will see all kinds of MCP servers are available. Even you can also search here what kinds of MCP servers you need. See here, MCP market. So here you can search what kinds of MCP servers you need. So GitHub MCP servers is available. Okay, Taskmaster is available. Cogni is available. Then Serena is available. Okay, that's why we are having different MCP servers. Okay, whatever you need, just try to use it from here. So here I'm going to use this Tabili MCP server, and how to use Tabili MCP servers, they have already written inside their documentation. So simply just write like Tabili MCP servers. You will see this documentation, and they have already given the guide. If you want to use this MCP server in Cloud, how to use that. If you want to use this MCP server inside your cursor, how to do that. Okay, all the steps they have given. Okay, but here we'll try to use this API functionality. So they have one API functionality. There is one URL. Okay, if you want to use this, their remote MCP server, this is the URL you have to use. Okay, so we'll be using this URL, and you have to provide the API key, Tabili API key, and if you hit this URL, right, you will be getting the servers. And for this, they have already given some kinds of commands. See, this is the commands they have given. Okay, so these are the commands we have to use, and if you are using these commands, automatically your server would be connected. Okay, and main benefit is that if there is any change in their API, Tabili will upgrade inside their servers. Okay, and it will automatically reflect inside your project. Okay, you don't need to change that. This is the main benefit. So yeah, let's try to use that. So let's open up our code editor, and inside this MCP test, first of all, let's import some library. Like I need operating system, I need this async IO, right? Because I have to use asynchronous programming inside MCP development. This is required. Then I need certify. Why you need certify? I think you remembered there is a path issue you'll be having in the Windows machine. So to prevent that, you have to use this certify library as well. Then you have to use this .env to load the environment variable. And we'll be importing this MCP client from LangChain MCP adapters. So from LangChain MCP adapters. Okay, inside that there is a class called client, right? And from the client itself, I'm going to import multi server MCP client. Okay, there is a function called multi server MCP client. So this thing we'll be using to create the MCP client. Okay, let me close. These are the file as of now. So we are creating this particular client. Now to prevent the path issue, we have to use this line of code, this HITL cert file and request CA bundles. Okay, we have to use this certify.while. Then we have to load the environment variable. So load environment variable. After that, we'll be loading all the API key, okay, one by one. So first of all, I need the Tably API key. So I think, remember, we have the Tably API key already. So this is the Tably API key. So let's load that. So Tably API key. Then I need to load the uh, aviation stack API key. Okay, so let's load all the API key, whatever I need as of now. Or here I'm only going to show you the Tably demo, right? So for this, I think Tably is fine. I'm only going to load the Tably. But apart from that, you need two more actually API key, which is one, you need this open weather. Okay, open weather API key, and anything you need. Let me just check. Tably is there. Aviation stack is there. No, only one API key you need, which is open weather API key. Okay, because I told you here we'll be creating another new agent called weather agents. Okay, and this need this weather API key. Okay, if you want to create this server, right, for this you need the API key. So this MCP, I'm going to show you how to create the custom MCP. Okay, for this, and to create this, I need the weather forecasting API key. Okay, so this thing will try to collect, and there is a website called Open Weather. Okay, I'm going to use that. So as of now, let's do it with the Tably. Later on, I'm going to show you how to do that part as well. So yeah, I think we have loaded the Tably API key. Now next thing we have to create the client. Now let's create the client. So client is equal to multi-server MCP client. Inside that, you have to give your MCP servers. Okay, see, this is the format. So make sure you are giving the same format. You given this curly bracket. Now inside that, you will try to mention all of your server. Okay, list of the server. So the first servers I need to add the Tably remote server. Okay, that means this server, Tably remote MCP servers. And for this, we are using this Tably documentation, and they're telling you have to use this. You have to use this kinds of command. Okay, so this is actually MCP configuration. You have to use this configuration. Okay, so I've already created this configuration. Let me show you. So that's how your configuration should look like. As you can see, this is the configuration. So first of all, you just try to give the name of the server. So this is the name, Tably. Okay, even you can also change this name if you want, but I have given Tably. And you have to mention the transport type. Okay, so I think, remember, inside my here whenever I explain about the model context protocol, right, so there I told you, see, we have two kinds of MCP server. One is the local MCP server, and it use STDIO transport type. That means to communicate with the MCP server, it use this STDIO, okay, communication. And for remote servers, it use something called streamable HTTP. Okay, so right now we are implementing this remote MCP servers, and for this we'll be using streamable HTTP transport. So that's why inside this transport like key, we are mentioning streamable HTTP. Okay, because this is a remote MCP servers. Okay, and what should be the URL? So this is the URL, and make sure you are copying the same URL from the Tably documentation. So this is the URL, as you can see. This is the URL. Just try to copy and mention it here. Okay, and here in this part, only just try to mention the API key. The API key, we are getting it from here. Okay, that's it. So if you just write this line of code, that means you have successfully connected one MCP servers with your MCP client. Okay, that much simple it is. Okay, now let me test whether it's working or not. So what I'm going to do, so here I'm going to write a function. This function basically return all the tools you have with your MCP client right now. Okay, so right now you can see this MCP client, the MCP client we have created, it has only one MCP server, which is Tably. So it should return Tably, and Tably having some tool. Okay, so this MCP server is connected with some kinds of tool. What is the tool? Tool means nothing but it's some kinds of function. Let's say what Tably does, it does the internet search operation. then it's give you real-time data. Okay, so these are the function it is having, and how it is extracting these are the information with the help of this API key. That means to implement one MCP servers, first of all you need to create the MCP client, right? MCP client you have to create, then you have to create the MCP servers. Okay, then inside MCP servers you will be having tools. Okay, different tools, and to implement these tools you need API. Okay, so this 4 step we usually follow to create one MCP development inside any kinds of AI agents. Okay, yeah. So now let me create that function, and make sure whenever you are creating the function you are using this asynchronous programming. Okay, because without asynchronous programming this will not work. So I'll be using async def. I'm going to name it as get all tools. Okay, get all tools. Now simply I'm going to write tools is equal to await. So if you're using async, you have to also use await. I think you remember I already taught you this asynchronous programming inside my playlist. Please try to check. It is already available inside my playlist. As you can see here, I already explained about this asynchronous programming. Okay, this is required. So that's why I'm using this await, and we are using this client, and there is a function you have to call called get tools. Okay, if you just call this function, it will basically list down all of the servers as well as the tools. Okay, with respect to their tools. Now after getting it, I'm simply going to print all of the MCP tools as well as their name. So yeah, this is the code. So here I'm printing available MCP tools, and we are running a for loop. So for tool in tools, okay, and we are printing all of the tool names. Okay, simple. Now let me test whether it's working or not. So for this, what I can do, I can open up this test file test.py, and previously I written some code. So what I can do, maybe I can remove this line as of now. Okay, so previously see I was using this direct tools, okay, direct tools, and I was adding inside my agents, but right now we'll be creating the MCP servers for that. See, previously for the tably search operation I created this function, right? I created this function, custom function, and if you give any query, so this will basically do the internet search operation, and this will give you the real-time answer. But right now I don't want to use that. Okay, I want to use this MCP servers I have here. It is already connected with the remote MCP servers, right, for the tably, and it is already having all kinds of tool you need for the real-time search operation. Okay, this is what we'll try to connect. So that's why I'm going to remove this code, and here I'm going to just write first of all I'm going to import async IO, then I'm going to import from MCP client test. Okay, import get all tools. That means this function I'm importing. Then after that, here I'm going to write if underscore name and is equal to underscore main, and inside that you have to just write async io dot run get all tools. Okay, so if you're using asynchronous programming, you have to run that event loop with the help of this async io dot run. Okay, so this is called event loop, and here this is the function we want to call. So this is not a simple function right now, this is asynchronous function. That's why to run this asynchronous function you have to use this async io dot run. Okay, now if I execute this code, now you'll be able to see all the tools would be listed down. Now if I just simply write python test.py, okay, see available MCP tools, tably search, tably extract, tably call, tably map, tably research. Okay, so here I don't need all of these tools, only I need tably search. Okay, if I want to do the real-time search operation, I need this tably search tool. And what is this tool? This is nothing but a custom function. Okay, this kinds of custom function they have written. This is nothing but this kinds of custom function they have written. Okay, but this is exposing as a tool. in the MCP server, remote MCP server. This is the beauty, right? And to perform this search operation, okay, in the custom function, they're using the API key. Okay, that's how things are working. I hope you get it. So right now, successfully you have connected with one MCP server, which is Tably, and it is having some kinds of tool we have already listed down. Okay, now here I'm going to write another function. So this function, what it will do, basically it will try to return only the Tably search tool, because here I'm having multiple tools. Okay, but I don't need multiple tools. I only need Tably search tool. Okay, for this I need to write another function. So here what I can do, let me show you. Yeah, so here I'm going to write another function. Yeah, so this is the function I have already written. Let me show you. This is the function. So this function returns the Tably search tool object. So as you can see, first of all, I have taken a variable here. Initially the value is none, and this is the function async def get Tably search tool, and I'm making it as a global variable. And first of all, I'm checking if this Tably search tool is not none. Okay, if it is not none, that means there is something, right? That time I'm just doing the returning operation. I'm just returning from this function. But if it is none, what I'm doing, first of all, I'm going through the client and I'm getting all the tools. Okay, then I'm looping through all the tools, and here we are doing the condition operation. That means here we are doing the generator, we are applying the generator function. I think you know, right? In Python we have something called generator function, and there we apply something called next, right? So here it will give you all the tools. So I'm doing next, 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 and once this is matching, like if tool name is equal to Tably search, that time I'm just storing this Tably search wire inside my Tably search tool. That means here. Okay, this is a very simple function I have written. So basically here I am having multiple tools, but I don't need all the tools. I only need Tably search tool. So these tools I'm just extracting from my all the tools, and I'm storing inside this variable. Okay, so once we have these tools, simply what I'm going to do, I'm going to return it, right? I'm going to return it. So for this, maybe I can create another function. So with the help of this function, we can do the real-time search operation. So this function name is async def tably MCP search, and this takes a query. Let's say user is given, tell me about the last match of FIFA World Cup. Okay, so this query will come here. First of all, I'm calling this function get tably search tool. Okay, and what it does, it will return you the tools, right? What tools? Tably search tool. Okay, where it will return in this variable Tably search tool. Here basically this tool would be saved, and we are using this variable, and we are doing the AI invoke operation. That means this is a tool object right now, and the tool object I can do the AI invoke operation. I think you know that, right? We are again awaiting the response because we are using asynchronous programming, and here we are passing the query. Okay, now it will do the real-time search operation. It will give you the result, and this result I'm returning. Now let me test whether it's working or not. So I'm going to come inside my test.py, and here I'm going to import this function Tably MCP search. Okay, Tably MCP search. So here what I can do, simply I can call this Tably MCP search. Just a minute. And here you have to pass a query, right? Yeah. So Tably MCP search, and let's prepare a query here. Latest news about AI. Okay, so this query I'm going to pass inside my Tably MCP search. Okay, this function. Now see, it will return you all the latest news. Now clear, and let's execute test.py. See all the MCP tools. Okay, now it is not giving you anything, because if you see here, it is returning the result, but I have to print it, right? So as of now, just to get it, what I can do, maybe I can print the result here. Okay, print the result here just to show you. Print result. Okay, Now let me execute it again. See, here is the response we are getting, and it is using different website, as you can see, and it is giving you all the latest news in AI. Okay, that means it's working perfectly. Okay, now we are not using this custom tool as of now. See, we are not using this custom tool. We are using the MCP right now. Okay, we are using the MCP, and from the MCP servers we are getting the tools, list of the tools, and we're utilizing this Tably search tool, and we're doing this kinds of real-time search operation. I hope you clear. Okay, so this is the experiment idea I wanted to give you, like how things are working, how we can create the client, how we can add the servers inside that. Okay, and how we can utilize that. Okay, now simply you can use this function inside your code. Okay, inside your backend file. Now let me show you how to integrate inside backend file. So as of now, what I can do, instead of printing, maybe I can return the result. Okay, because right now I want to use it inside my app. That's why instead of printing, I want to return the result. Okay, now here what I'm going to do, I'm going to open up my backend.py. Okay, so inside backend.py, I think you remember I was importing these tools, Tably tools, Tably certs. Okay, so initially I was using this Tably certs here inside my hotel agents. Okay, hotel agents need the Tably certs, right, to find the best hotel inside location, right? So here I was using this custom function, but right now I don't want to use this custom function. I'll be using my MCP servers. So for this, simply I'm going to comment this code. I'm not going to delete, guys. I'm going to comment just to show you the changes I'm doing. Okay, so here I'm just I'll just do the comment, and let me show you how to add that. So after that, let's yeah, so you have to import MCP from MCP client test, from MCP client underscore test import. You have to import this function, this Tably MCP source, right? So once you have import, now you have to go to your hotel agent where you are using your Tably search, right? So here in the hotel agents, I'm using the Tably MCP search. So instead of this, right now, what I have to do, I have to write this code. Let me show you. Yeah. So I have to write this code. Let me comment this line and add this line. Okay. So again, you have to import this async IO. So let me import. I'm going to import it here. Import async IO. Okay. So with the help of async IO, you have to execute that function here. So async IO dot run Tably MCP, and whatever query you are getting from the user, you are passing it inside the function, right? And this will give you the result, and this result you are returning to the agents. Yeah, that's it. And you don't need to change inside your app.py because app.py is already updated, right? Here we are only invoking the route. So only you just need to change inside your backend.py, because inside backend we are creating all the agents, right? Now this agent is using MCP. Okay, it is connected with the MCP. So this architecture we have developed right now. See, these hotel agents we had, right? So previously I was using the Tably custom function, right? But right now we have connected with the Tably MCP tool, which is a remote tool. Remote MCP server, right? And this MCP server is having some kinds of tool, and we're using Tably search tool only. And this Tably search tool is using Tably API key to get the response. Okay, I hope you get it. That means this connection we have done. Now the benefit would be, if there is any change in the API, okay, Tably will try to upgrade in their server. Okay, and it is automatically reflect inside your agents. That means you don't need to change this code. This code you don't need to change anymore. Okay, this code you need to change anymore. Automatically Tably will take care of this part, and your MCP client will load that. This is the beauty of MCP. Okay, I hope you get it. Now let me test whether it's working or not. So right now this Tably tool is not required. You can also delete, but I will keep it just for your reference. Okay, or I think you can delete it as well, because this is not required, right? So what I can do, I can delete this Tably tool. This function I can delete. or let's keep it. Okay, just for your reference, I'm keeping it here so that you can refer, okay, where I have done the change. So I'll keep it. Now let me test whether it's working or not. So close it. This is my client and this is my backend. We have already added this tably search MCP. Now let's execute my app.py. So I'm going to open up my terminal, clear. So python app.py. It should work. Let's see. Running. I'll open up my localhost port number 8000. This is running. Now let me give a plan a complete 7 days Japan trip from Bangladesh, including flights, hotels, and sightseeing under 2 lakhs. Now generate the plan. Okay, I told you one issue you'll be getting if you're not using this nested async IO library, right? Because right now there is 2 event loop is running, right? That's why you can see async IO dot run cannot be called from a running event loop. Okay, that means one event loop is already running here, right? Inside my app.py, we're using already async bonus programming. So if you want to run the multiple event loop, so you have to use that library. So this part I forget to add. Let me show you. So there is a library we already installed, right? I think you remember, called nest async IO. This is called nested async IO. Okay. So I'll try to add inside my app.py. So I'll open up my app.py and here you have to add this line. You have to add this line of code. That's it. Okay. So this allows nested event loops for async call in fast API. Okay. So we're importing this nest async IO and we're just calling apply function nest async IO dot apply. Okay. If you do it, it will handle the multi-event loop right now. Okay. So yeah, let me save and let me re-execute the code again. Running. So I'll open up, refresh. Now let me give this plan again and generate the plan. So see guys, perfectly it's working. As you can see, this is the trip summary, this is the flight information, and this is the hotel suggestions. Okay, now this hotel suggestion is coming from the MCP servers. Okay, this is not a custom function anymore. Congratulations guys, you have successfully created your first MCP servers. Okay, you have connected your first MCP servers with your client. And this is by day by day itinerary and estimated budgets and final recommendation. Okay, amazing. Our first experiment is done and it is working fine. Okay, so like that we'll try to add our next things, which is the flight MCP, right? That means the aviation stack MCP. So that means to get the flight information, previously I was using this custom function, right? Inside the tool I was using this flight tool, and this is the big custom function I have written, and there I was using this aviation stack API key, right? Here I was using aviation stack API key and I was hitting this URL, right? And this is the entire function I have written. But right now we'll try to convert as a MCP server and we'll be using the tool from that, right? So this part I'll try to add, and for this we'll be using local MCP. Okay, so see, this aviation stack doesn't have any remote MCP server. Okay, so like I used this Tably one, right? This aviation stack doesn't have any remote MCP servers. It has the local MCP server. Someone has this created already. This is available inside a GitHub. Let me show you. So this is the GitHub. This is the GitHub. This GitHub is from this user. So this is aviation stack MCP. Okay, and this MCP he has created for the local. Okay, local machine. This is not running on remote. Okay, so we have to set up everything in the local, right? So here they have given already the MCP server configuration. So we'll try to use this configuration without cloning this repository. Okay, this configuration we'll try to use for that. But if you want to clone this repo, okay, and set up, for this you have to use this configuration. There you have to give manual path directory, but I don't want that. I will be using this one. Okay, this one would be more easy to use because here I don't need to set up their GitHub repository. Okay, so this thing will try to run in the local. Okay, that means with the standard IO communication we'll try to do. Okay, let me show you how to add that as well. So right now instead of writing inside my MCP client tests, what I can do, maybe I can create a final file here. I'm going to name it as MCP underscore client. Okay, .py. And here, what I'm going to do, I'm going to copy my previous code. I'm going to copy my previous code. So right now, I'm going to load two API key. One is for Tably API key, one is for Aviation Stack API key. Okay, because right now I want to add this flight information as well. For this, I need Aviation Stack API key. Okay, so I'm loading all of the API key, and here I'm going to copy my server. Sorry, client, and inside it we have the server, right? Let's copy this code, and to get the tools, this is the function I have written. This will return all the tools available. And right now what I have done, let me show you. I have written a single function. Okay, instead of writing multiple function, I have written a single function. So previously, I think remember, I written a single function to get the Tably search tool, right? So this was actually searching like whether it has the Tably search or not. Then it was returning. So what I can do right now, I can also I will be also using Aviation Stack, right? Aviation Stack like MCP servers, and I told you we'll be creating the local MCP servers. Okay, and from here we'll try to get these servers from this GitHub repo. So you just need to copy this code. Okay, copy this code. I think till here you have to copy. Okay, so make sure you are copying till here. Okay, and you mention after your first server. Okay, make sure you give a comma. After that, just try to mention the next server. Okay, make next server. Now, if you want, you can also change this name. You can change the name. I can name it as Aviation Stack MCP. Okay, and here you have to add another parameter, which is transport. So right now this transport should be stdio. Okay, studio. Why? Because this is local MCP server. Okay, and to communicate with the local MCP server, I have to use this stdio, standard output, input and output. Okay, this transport type. And command, they're executing UVX command to get their see what will happen if you add this line, right? If you add this configuration, it will automatically get this GitHub, right? And in this GitHub they have already written the code related this Aviation Stack, right? Like how to get the flight informations. Okay, for every let's say operation, they are having their custom function. Okay, like previously written, right? Yeah, previously written here. So these kinds of function they have also written, okay, inside their code, okay, inside this GitHub repo. But they have exposed these are the function as a MCP tool right now. Okay, so their tool I want to use. That's why I'll be using their configuration. So if you're using MCP, right, you have to always use this configuration. With the help of this configuration, you can get any kinds of remote as well as the local MCP servers. For custom one, definitely you have to create your own custom function, but for remote and local, you have to use this configuration. Okay, I think you get it. So basically, it will get this Aviation Stack MCP GitHub repo. See, this is the name of the GitHub, Aviation Stack hyphen MCP. So we're giving the same name here. Okay, it will get the GitHub repo, and it needs the API key, Aviation Stack API key, and here we have to pass the API key right now. Here we'll be passing our API key, the API key we're loading. Okay, that's it. So if you just add this line of code, this line of configuration, now it will load the Aviation Stack MCP. It will load all of the tools it has, and you can use that tool. Okay, now let me show you whether it is connected successfully or not. So maybe I can call this get tools, and I can see whether my aviation stack tool is available or not. So again, I'll try to open my test.py. Instead of calling this, I can call my get tools again. Clear Python test.py. Okay, one error I'm getting, which is a coroutine was expected. Let me check, guys, what is the problem. Oh, okay. The problem is that still I'm executing my this one MCP client test, right? But I have to execute this MCP client because everything is available inside my MCP client.py, right? From this file. So here I have to change that. So instead of writing this, I can comment and write from MCP client import get all tools. And here I have to give this parenthesis. Now it should work. Let's see. See, available MCP tools. First of all, definitely we had the tably. Okay. Now see, these are your flight tools as well from the aviation stack. As you can see, flight with airlines, historical flight by dates, flight arrival departure schedule, future flight arrival and departure schedule, random aircraft type, random airplane details information, random countries detail information, random cities information, list airport, list airlines, list route, and list taxis. Okay, so these are the custom tools they are having. These are the custom functions they have written in their GitHub. Okay, in their GitHub. If you check their GitHub, these are the custom functions they have written. Okay, see, if you say check their server, these are the custom function they have written. Okay, and we are able to get this as a tool. They have exposed these are the function as a tool. Right now I can use this function as a tool. Okay, so from here, what are the tools I'm going to use, guys? Okay, what are the tools I need to use? I need to use this get airports as well as the airlines. Okay, I think if I get these two information, I think this is enough for us. Okay, for our agents. Again, let me check whether this is fine or not. Yeah, so I only need list airports as well as the list airlines. Okay, these two tools I need. First of all, I will get all the airports, I'll get all the airlines, because for my travel agents, okay, I need to see the airports as well as the airlines. Okay, for one country to another country. These are the information I need. But if you want to use any other function, you can use that, okay, as a tool. So for this, what I can do, maybe I can write a final function. Instead of writing multiple function, I can write a single function here. Yeah, so this is the function I have written. Okay, tably and aviation tool. So this function returns the aviation tools as well as the tably tools. Okay, tably tools, and this is the same function I have written previously, whatever I written inside my MCP client test. As you can see, this is the function, but this is like more detailed one. Basically, it returns two things. One is the aviation tools as well as the tably search tool, but it was only returning the tably search tool. Okay, so as you can see, first of all, we are making this two variable as global. Then I'm checking search tool is not none. Okay, and aviation is not none. If it is not none, we are returning. Otherwise, we are looping through the tool. Okay, and first of all, we are upgrading the tably search tool. Okay, I need only the tably search tool. Then for the aviation, okay, instead of tably search, whatever tools are available for the aviation stack, right? For this list airport, list airline, okay, whatever I have, I'm storing inside this dictionary. Okay, because this is a dictionary I have taken, right? And once I am able to save these at the tools as a dictionary, now I can use any of them. Okay, either if you want to use the list airlines, either if you want to use the list airports, you can use any of them. Okay, that's why I'm storing inside the dictionary. Now for the tably MCP search, this is the same function I have just copy pasted. This one. Okay, this one I've just copy pasted here. So it takes the query and it returns the real-time updated data from the internet. Okay, and for the aviation stack, this is the function we'll be using. So I have written async def aviation MCP call. Here, first of all, you have to give the tool name. Okay, tool name. So what is happening? See, right now in this dictionary there would be all the tool name, right? All the tool name for the aviation stack. But you have to tell which tool you have to use. Let's say I want to use list airports and list airlines. I'll just give the name here. I'll just give the name here. So what it will do, automatically it will list down all the tools. Then again it will loop through that. Okay, and it will match whether this tools is matching with the user tools name or not. If it is matching, okay, we are storing inside our variable and we are doing the AI invoke operation and we are returning it. Okay, very simple. So basically this will filters which tool user should use from all the aviation stack, whatever tools you are having. Okay, this is the idea. And this is already connected with the MCP server, with my MCP client. So this MCP client is getting the server, and in this server we are having all the tools, and all the tools are using the aviation stack API key. That's how things are working. Now let me show you how to integrate inside our application. So for this, again, what I can do, I can open up my backend.py. So here I'm going to first of all import. See, right now this flight tools, search flight tools is not required from my tools because initially I was loading it manually from my function. So right now I'm going to comment this line as well. Okay, this is not required. So here I'm going to import everything. So instead of importing from my MCP client test, I'm going to import from my MCP client only, because MCP client should be my final file. Okay, inside that we have already written the tably MCP search. So let's write my other things as well. So let's import my aviation MCP call. That means this function, aviation MCP call. Okay, this aviation MCP call basically will return whatever tools you need. So here I'm going to import it here. Aviation MCP call. So after that, let's upgrade inside my code. So this aviation, where I need to add inside my flight agent. Okay, let's go to the flight agent. Okay, so here is my flight agent. Yeah. So see what I'm going to do. I'm going to just upgrade this flight agent with more detail instead of just simply returning the information. So right now, what I want to add a large language model. Okay, so this large language model will try to get these are the informations. That means my flight information. So I already have the tools, list airport and list airlines. Okay, I'll give these informations to my LLM, and I'll try to ask my LLM to generate some informations like departure time, okay, arrival time, then route, typical flight duration, estimated flight budget. Okay, so these are the information I'm going to generate from my large language model by providing these are the information. Okay, so what I can do, I can maybe comment this function, the function I've created. So let's comment this. And let's add my new function here. So let me show you my new function. So this is the new function I have created, guys. Very simple. Only I have added a large language model. See, first of all, I am preparing a prompt, flight agent prompt. So here I'm telling you are a travel flight expert. User will give the query, right? Take the query as well as take the airport information like airport data as well as the airlines data. That means we'll try to give airport data as well as the airlines data from my tool, right? and you have to generate likely departure airport, likely arrival airport, airline serving this route, then typical flight duration, estimated airfare, okay, range or budget, then peak session pricing warning, booking advance. Okay, so these are the things I want to generate. So for this, I have written this function called flight agent, and this should be a actually a node, right? We are using LangGraph, and this should be a node. And for this, we are passing my state, travel state, and already we have prepared the travel state. I think you remember, right? And we have this flight result variable there. So here, yeah, where is that? So we are passing this travel state, then we are printing the information like we are inside now flight agent right now. Then we are taking the user query and we are doing that MCP call. Okay, so we are again using async IO run aviation MCP call. Okay, we are calling this function. Okay, and this function takes tool name. Okay, which tool to use? Okay, it takes the tool name, like which tool you want to use. So I want to use list airport. That means these tools, list airports. Okay, so automatically it will return that list airport tools, and we are doing the invoke operation, AI invoke operation, and it is giving you all of the airport list, okay, inside this variable. And second, I'm invoking my list airlines tools. Okay, this one, list airline tools, and again we are giving this name list airlines. We are invoking, okay, because inside this function we are invoking, I think, remember. So here we're doing the AI invoke, okay, and we are getting all of the informations. All of the informations we are storing inside this variable. Then we are printing those information inside terminal just to see whether we are getting the information or not. Then after that we are preparing the prompt. Okay, so previously we created the prompt template. Okay, this is the prompt template. Now we are formatting the prompt here. So prompt flight agent prompt dot format. We are giving the query, user query, airport data, and airlines data. Instead of giving all the data, I'm giving that many of word. Okay, that many of information. So this is kinds of word limitation we are giving just to show you, because if I'm passing all the informations, there are lots of airport airlines informations are available. So again, what will happen? My token limit would be increased, and I am using free model, right? This Grok model, Llama model, I think you remember, right? We are using Grok provider. So my free limit would be over. That's why, just to prevent the limit, I'm passing some information, just passing some airport information, okay, instead of all the airport informations. But if you're creating the actual agents, okay, for the production grade, that time just delete this line. Okay, make sure you delete this line. Okay, you can take all of the airport and airlines informations. Then after that, we are using the large language model. Which large language model? Our same large language model we have initialized here, this Llama 3.3 model. Okay, versatile model. We are invoking this model, right? Yeah. Then we are giving the system prompt. You are a expert travel flight planner. We are giving the prompt. Then it is giving you the response. We are taking this flight data variable. We are storing the response, and we are returning it as a flight result. Okay, inside my state. Okay, same thing. Only I just added a large language model call here. So this is the same function. See, same thing. We are returning the flight data only, but initially I was getting the flight data from my custom function, and I was directly returning. But right now I'm using a large language model, and I'm using these are the informations to generate some more information, so that my agents can have a good amount of information to give you the idea about the flight information. Okay, so previously the flight information was slightly, let's say, low level, I mean high level, right? Like it was only giving you some flight name and so on. But right now it will give you the flight budget, flight location, each and everything it will provide you because of this function. Okay, so these are the upgrade I have done. So successfully we have added this connection as well. That means in my flight agent we have successfully added my aviation stack MCP servers, and this is local MCP servers. Okay, this is not a remote MCP servers, because here we are not using any kinds of URL. Okay, we are cloning a GitHub repo, and this GitHub repo, it will set in your local. Okay, it will start in your local and will try to communicate with the tool. Okay, for this we have added this line of configuration, this configuration. Okay, and transport is equal to stdio. But if you're using remote, it should be using streamable HTTP. Okay, but whenever you are creating your AI agents, make sure you are using all the server as a remote server. If you're using remote server, definitely there is a benefit. Okay, because it is running remote, and everything you are using from remote. Okay, you don't need to set up everything in manually, right? So try to use all the remote server, but if you don't have remote server, in case that time you can use local MCP server. But let's say if you don't have the local MCP server as well, if you want to create your own custom MCP server, this is also possible. This part I will also show you in my next next update. Okay, next update means after this demo, after testing this, I'll try to add inside my um, code. Okay, that weather one I'll try to create my custom MCP server. Okay, so I think this is done. We have successfully added our flight agent. We have upgraded the flight agent with the MCP. Now let me test, okay, whether it's working or not. Now I'll clear. Again, run my app.py. Running. I'll go to my app. Refresh. Okay. Now let me give this plan and generate the response. Even you can see the terminal. So as you can see, guys, it is able to get all the airports data, okay, as well as the airlines data. Okay, as you can see, all the airlines, all the airports, and these are my MCP tools. And see, we are using list. We are using this list airport and list airlines. Okay, for this we are getting this information. And see, this is my final response. I'm getting trip summary, flight information. Now just try to check this flight information and try to compare with your previous version of the project. Okay, previous version I was only using a single function. There it was giving as a high level, but right now it is giving you the detailed information of the flight, like this departure airport, okay, Dhaka, arrival airport Tokyo, airlines, which airlines you have to take, flight duration, approximate, like how many hours it may take, estimated aircraft budget, okay, how much budget you have to give, booking in advance, okay, how to book in advance, everything it is giving you as a detailed information. This is more good, better version than your previous one. Okay, I hope you get it. This is the hotel suggestion, this is the day by itinerary and estimated budgets and final recommendation. Okay, so yeah, so everything is working fine. Only what I can do in the UI, I can maybe upgrade, because this looks like my previous project. Okay, so maybe I can upgrade in my UI. So I'll open up my index.html, and here a multi-agents travel planner with LangGraph and MCP. Okay, so let's try to add this line. Sorry. Now if I come here, refresh. Now yeah, it looks good. Right now I have added this MCP so that I can differentiate. Okay, this is my MCP version. Okay, and this was a previous one, my without MCP version. Okay, so everything is fine, everything is working, we are good to go. Now next part, we'll try to upgrade. Flight agent is complete, hotel agent is also complete. Now let's try to add this new agents, okay, which is my weather agents. Okay, and itinerary agents is already there. We have to only upgrade this weather agents there, and flight agents also already there. We have to upgrade this weather agents there. Okay, and we'll try to combine all the agents together. We'll try to again create the graph. Okay, we'll try to compile the graph and our agents would be ready. So now last part, we have to add this weather agents. Okay, and for weather agents we'll be using weather MCP server. Okay, and here we'll try to create our custom MCP server. Right now I'll show you how to create the custom MCP server. We have already seen how to create the remote MCP server, how to use the local MCP server. Now let's see how to use the custom MCP server. Okay, all of the server I'll try to cover. Okay, so to create the custom MCP servers, guys, what I can do, maybe I can create a new file here. I'm going to name it as custom weather MCP server .py. Okay, inside that we'll just write the code. So first of all, let's import some necessary library. I'm going to import from MCP dot servers dot fast MCP, import fast MCP, fast MCP. Okay, so this is the like a Python library we use to create the MCP server, and we already installed inside my requirement.txt this MCP. Okay, so with the help of that, we'll try to create our custom MCP server. Then I need request library to perform the API call. So import request as well. Okay, and request is already installed here. I think I remember what is already installed here. Then I need to import the operating system as well. Import OS. Okay. Then I also need to import the environment variable. So let's load the environment variable. Now let's define the MCP object. So MCP is equal to fast MCP. Inside that you have to give the name. So this is my weather MCP server. Okay. So I don't need to give the port. It's fine weather MCP server. Okay. Now I have to collect one API key. Okay. So to get the weather information, as you can see, to get the weather information, I will be using this platform called Open Weather. Okay, Open Weather API key. Just try to search like Open Weather API key in Google. There is a website called Open Weather. Just try to open it up. And there is an option called Get API key. Just click here. First of all, make sure you create an account. Okay, if you don't have account, just try to create one account. So I already have the account. I'll just try to fill the information. Okay, login successful. Now I'll go to the API section, get API key, API key. Okay, now this is my API key. Okay, so I already collected this API key, already created, but if you don't have, just try to generate API key, give the name and generate the API key. Okay, I already created some API key. So don't use my API key, guys. I'm going to remove after this recording. So let me add my API key inside my environment. So this is my Open Weather API key. Okay, this is my Open Weather API key. Now I have to also load it. So here I'll try to load this API key. Okay, Open Weather API key, because I'll be creating my custom server, right? To create the custom server, first of all, I'll be using my custom function. Okay, inside the custom function, I'll do the API call. So with the help of API call, I'll get the real-time weather informations. Okay, and this function I'm going to expose as an MCP tool. This is the idea, right? Yeah. So see, I already written a function. Let me show you. This is a simple Python function I have written. So if you give any city name, so this will return you the forecast. Sorry, the current weather. So if you give any city name in this function, it will give you the current weather. How it is giving you the current weather? Here we are calling this API. Okay, so this is the Open Weather API, right? We are calling this API. We are giving the parameter like city, the API key, as well as the metrics. Then we are sending the request with the help of request library. It is giving you some kinds of response. We're getting the response. First of all, it's checking whether this response it is not equal 200 or not. If it is not equal to 200, we are returning the data, whatever data we have. Otherwise, we are returning the these are the informations, like we are returning city name, temperature, feels like, okay, humidity, condition, wind speed. These are the information we are returning. So this is a simple custom Python function I have written. Now one question would be in your mind. So here we are using our custom MCP, right? Custom MCP. We are creating our custom MCP servers, custom MCP tools, right? So if there is any API change, then what I have to do? So definitely if you're creating as a custom, right? If you are the author, so definitely you have to take care of this part. Let's say in future, Open Weather, if they change this API version with 2.5 to 3, that time you have to upgrade inside your code. Okay, and you can also deploy this MCP servers in the remote cloud. Okay, you can also make it available for the public, like we use Tably one. It is available in public, right? You can also expose your MCP server in public. Okay, public can use your MCP server. It is also possible. Okay, but right now we are running inside our local. But as of now, whenever you will be creating your own MCP server, make sure you will try to host that as well. Hosting is also super easy. Maybe in other video, I'm going to show you how to host that MCP server. This part is also very simple. Okay, now see, this is not the MCP tool right now. if you want to make this function as a MCP tool, if you want to expose this function as a MCP tool, you have to use this decorator only. MCP dot tools. Okay, if you just write this decorator, now this is not a simple Python function right now, this becomes a MCP tool. Now it is exposed as MCP tool. Okay, you can use it from MCP server right now, MCP client right now. Okay, amazing. So like that, I'm going to create another function called get forecast. Okay, again, if you give the city name, it will hit that URL, it will get the response, and I'm getting the forecast data, like we are getting the dead time, temperature, weather information, we are getting the forecast. Okay, so these two function I have created, again I'm going to expose as a MCP tool. Okay, that's it. Now this is my custom MCP server we have created, right? Custom MCP server we have created. Now I have to run this server. Okay, so right now it is not running in my remote, right? It is not running in any cloud. It should be running inside my local. And how to run in local? For this, you have to execute this line. Okay, mcp.run. So it will run inside your local. Automatically, it will take this std io transport type. Okay, and whenever I will use it inside my client, that time I have to also mention that, right? Okay, as a configuration. Now let me show you how to mention as a configuration. See, we have created this file, and this is my custom MCP server right now for the weather information. Now let's update inside my MCP client. So now I'll open up my MCP client, and here let's load my open weather API key as well. Okay, and here I'm going to add my configuration. Let me show you. So that's how you have to add the configuration. So again, I'll give a comma, and this is my third MCP server I have added called weather. Transport type stdio, because this is a local. Okay, this is a local one. Okay, this is a local one. It is running on local. Then command. See, this is the Python file, right? The MCP server we have created, this is a Python file. So to execute this Python file, I need a Python client, right? And where I have this Python client is available inside my environment. Okay, let me show you. By default, if you create your Anaconda environment, so it will be available inside your local C drive. So here I have installed my Anaconda. I'll go to my Anaconda. There is a option called environment. I'll go to the environment, and this travel environment I created for this project. Okay, I'll go inside that. Now here you have a Python client. See this python.exe file. Okay, so this client location you have to give. Just try to copy this location and paste it here. Make sure you are giving your location, not my location, guys. Okay, everyone location would be different. So just try to find where you have installed your environment. Just try to give this location here. Make sure you are giving the same location and mention the R, because this is a Windows path. That's why it's using backward slash. That's why I'm giving the R. Okay. So this is the command. So with the help of this Python client, it will execute this file. And what should be the file location? You have to mention inside the arguments. Okay. So this is the file location. Where it is available? So let me show you. This is available inside my project. This is my project environment, right? So this is the file I have created. Just try to copy this location, the entire location. Okay. This is available in my DSwithBappy, coding, YouTube. Okay. This is the folder. So this folder location I have given here, as you can see, and we are mentioning the file name. Okay, again we are given the R because this is a Windows path. So these two things you have to only change if you are using my code. Make sure you are using your location, okay, not my location. And here you have to pass your open weather API key. That's it. Okay, now this becomes your server right now. This will automatically connect with your server because this server would be running in your local. We have already executed in the local, as you can see, mcp.run. Okay, and we have already mentioned the type, transport type stdio, because this is running on local. Okay, that's it. Now what I'm going to do, guys, simply, okay, I'm getting some error. Let me check the error. Okay, there should be another bracket. I think I missed out on bracket. Now I think it's fine. Okay, now you can check. This is the format. Okay, so make sure you check the format. Format should be exact like that. Okay, yeah. So yeah, we have successfully added our MCP server inside my client. Now let's upgrade in the code. So first of all, I'll write some function related that weather tools. Okay, I'll just write the function related weather tools. So these are the function I have prepared for the weather tools. As you can see, we have taken two variable, weather tools and forecast tools. Okay, because I have written two functions. One is for forecast, one is for weather. Okay, so these two information I'm going to save inside two variable. So this is my function name, initialize weather tools. We are making it as a global. First of all, we are checking this tool is empty, this variable is empty or not. If it's empty, I'm returning. Otherwise, I'm getting the tool. Okay, then I'm getting my get current weather tool. Okay, let me show you how many tools you have inside inside your server. So here I only have two tools. One is the get weather and the get forecast. Okay, so let me list down. First of all, let me show you. So let's say I'll delete this code. First of all, let me show you. Then I'm going to show you this code. This is the aviation, right? This one I have to delete. I have to delete. So let's open up my test.py. This is already connected with my MCP client and get tools. Okay, now let me list down all the tools. Clear. Python test.py. See, we have Tably, we have flight. Okay, we have weather, get current weather and get forecast. That means this two function. Okay, this two function you can see, and this two function right now it's a MCP tool right now. Okay, we are exposing as a tool. That's why it is listing as a tool inside your server. Okay, that's how we can make our any kinds of custom MCP server, and we can expose all the function as a tool. Okay, anything, just try to think what are the things you need. If you don't find the remote one, you can add this custom one that time. Okay, and you can expose any kinds of function as a MCP tool. This is possible. Okay, so yeah, everything is available now. Simply we can add inside my client. Now let me get back to my previous code. Yeah, so yeah, this is the function I have written. So basically this is getting my weather tools. It is updating in the weather tools. Okay, get weather, and this is upgrading my forecast tools. Okay, get forecast tool. That means these tools I'm extracting from all the tools out there. Okay, and upgrading inside this variable. And once we have upgraded inside the variable, so here I have written another function called weather MCP servers, and it is initializing this function, and this function upgrading this actually variable. And here we are giving user is giving the city name, and it is doing the invoke operation. Okay, so it will invoke the weather tool. Okay, weather information, and this function will invoke the forecast tool. That means the forecast information. That means this function. Okay, one will invoke this function, another one will invoke this function. Okay, so this is what we are doing here. That's why I've written multiple function, and we're using async await. Okay, because this should be running as a asynchronous way. Okay, in parallel. So it will not wait, let's say, for another tool to be complete. It will run all the tool in parallel. This is the idea behind this asynchronous programming. Okay, yeah. Now one more thing. See, user here, if I show you my app, so user is giving the prompt like that: plan a complete 7 days Japan trip from Bangladesh. Okay, so user is giving prompt like that, but from here I have to automatically extract the city name. Okay, let's say the country name. Okay, so how will you get the country name? So for this, I'll create a function here, and there I'll be using a large language model. With the help of large language model, I'll automatically extract the city name from the user query. Okay, so here let me show you destination extractor. Okay, I'm going to name it as a destination extractor. So this is the function. So here I've given the prompt: exact only the destination city or country user whatever query user is giving, and return only the name. Okay, so here we'll do in the llm.invoke operation. So let's use a LLM here. So I'm going to import the same large language model from Grok. So from langchain underscore Grok, import chat Grok, and here I'm going to initialize the large language model here. Okay, and make sure you also import the Grok API key. Yeah, we are using Llama 3.3 7 billion versatile model here. Okay, so yeah, simply this code I have to add, and now let me check everything is fine or not. Yeah, everything is fine. Now I'll use this destination extractor to extract the country name or city name, whatever user is giving, and I'll just try to return to my forecast. Okay, forecast and weather MCP. Now let's try to add inside my code. I'll open up my backend.py. So I'll import it first of all. Let's import. First of all, I will import my extract destination, forecast MCP search, and weather MCP search. Okay, that means this is the extract destination, forecast, okay, as well as the weather MCP. Okay, all of these things we are importing here. So after that, we'll try to upgrade inside our code. Yeah, so now let me go below. Yeah, now this should be my new agent, okay, which is weather agent, and where I have to add after the hotel agents. Okay, so let's go to the hotel agent. Flight agent, hotel agent. Okay, after hotel agent, I'll try to add my weather agent. So I already created the weather agent. Let me show you. So this is my weather agent, guys. Okay, weather agent, and I'm again giving the state. Okay, state I'm passing, and we are calling this extract destination. First of all, whatever user is giving the query, I'm extracting the city name or country name, whatever user is giving, with the help of this extractor. Okay, after that, we are calling the weather MCP search first of all. That means this tool first of all. Okay, then we are getting the weather data. Then we are calling the forecast. That means this tool. Okay, and we are getting the forecast data. Then we are preparing this message, weather result and the current weather. We are passing the weather and the forecast, and we are returning it. Okay, and we also need to upgrade this weather result variable. Okay, inside my state, let me show you. If I go to my state, see there is no weather state variable. So let me add that as well. Weather result. Okay, I'm going to name it as weather result. Okay, this should be a string type. Now if I go below, now this weather result would be upgraded. Okay, that's it. Now we have added our new agent. Now we have to also change this itinerary agent because it has the user query, flight agent, hotel agent information. What about the weather agent? I have to also add that. Let me add it. So here, after hotel agent, I'm going to add this weather result as well. Okay, whatever weather result I'm getting from here, I'm going to add it here. Okay, now let me check if anything I need to change or not. No, I think everything is fine. Now next, I have to upgrade my final response agent. Okay, inside final response also, I'll try to add the weather information after hotel. Okay, see weather, we are giving the state weather result, and we are also changing the prompt. So I'll also upgrade this format. See, this is the upgrade. So here I have added this weather information. Okay, this weather information I have created, but previous format it was missing the weather information. Okay, now it will give you trip summary, flight information, hotel suggestion, weather information, day by day itinerary, estimated budget, and final recommendation. And there we're giving some important messages as well. Yeah, so I think everything is fine till here. Now we'll have to build the graph. Okay, now in graph also we have to add this weather agents. Now let me show you. Okay, now let's update our graph. This is the updated graph. So only the things I have added, which is this weather agent. Okay, and we have done the connection here. Yeah, so I think everything is fine. Now let's open it up. Okay, so everything is fine. Now only the change I have to do. Now this compilation I don't need to change. Yeah, so here I have to give this weather result. After hotel result, I have to pass this weather result. This should be a string. Then at last, I'm going to return my weather result as well after hotel. Okay, weather result, and this will return you the weather result. Yeah, so I think this is the update we have to do. Now I think everything is fine. Let me check again. My client is ready. My backend is also ready. We have upgraded this weather agent. Now let's execute my app.py and let me test, okay, whether it's working or not. So I'm going to clear the terminal and let's execute python app.py. It's running. Now I'm going to reload my application. Yeah. Now let me test, guys, whether it's working or not. So let's say I'll give the same plan. Now let's generate. Now let's see the output. Even you can see the execution in the terminal. Now it is inside flight agent. It is getting the flight information. Now see, these are the flight information, airports and airlines with the help of the MCP tool we are getting. And we are having, these are the MCP tools. Okay. So yes, guys, I got the plan. As you can see, this is the trip summary. This is the flight informations, all of the flight information, as you can see, with estimated budget and everything. Then hotel suggestions, and the new sector we have added this weather informations. Okay, with our weather agent. That means this agent. Okay, this agent is working right now. Now this is the weather right now in Japan. Even they are breaking down the weather condition. Okay, day by day. And this is your itinerary plan, estimated budget, and final recommendation. Okay, now let me try with another one. Let's say Dubai. I want to go to Dubai from Dhaka. Let me generate another plan. And this application is running completely with the help of MCP. Now we are not using any kinds of custom function here. Okay, everything we are running with a MCP connection. Yeah, so see, all of this information we are getting, the flight information, then hotel suggestions, weather informations, day by day itinerary, estimated budget, and final recommendation. Okay, if you want, you can download, even you can also copy that. Yeah. So yes, guys, we have completed this architecture. We have completed our multi-agent system with the help of MCP. Now I think you can understand, you can use MCP with your any kinds of AI agents development. Okay. And I already told you why MCP is required, why agent needs the MCP, what is the advantage to use the MCP. Each and everything I have clarified. Even I also showed you how to create the remote MCP server, how to do the local MCP server. Even I showed you how to create the custom MCP server as well. Okay, each and everything I have clarified. So guys, now I will start working on the part 3 of this project. So here we'll try to add the supervisor agent as well as the guardrails and HITL, that means human in the loop. So far we have completed this project till part 2. In part 2 I showed you how we can integrate the model context protocol. So there I showed you actually 3 kinds of like MCP server. One is the local MCP, another one is the remote MCP, another one is the custom MCP. Okay, so all of the MCP like servers I have already covered, I have already showed you in this particular implementation. And in our part 1 we have seen the simple implementation without using any kinds of MCP server. So now I think you are getting the step-by-step idea like how things are working and how let's say we are making one particular agent like more advanced by adding some more amazing technologies, and all of the technology we are already covering inside our playlist. So if you check my playlist, guys, everything I have covered inside my playlist. So please try to go ahead if you are not familiar with any kinds of concept. So if you complete the entire playlist, I think it would be easy for you to implement this kinds of advanced project. Okay. So in this part 3, guys, I'm going to show you the guardrails integration. Okay, so this guardrails part I have already covered on my playlist. Please try to go with this particular crash course, then you can continue with this architecture, the new architecture. Okay, we'll try to develop right now. And apart from guardrails, we'll try to add some more like more amazing let's say functionality inside this agent. That means we'll try to add the supervisor agent right now. So why this supervisor agent is required, I'll tell you. And we'll also try to integrate this HITL, that means human in the loop. Okay, and you know what is human in the loop and how it works. So for this again I have the tutorial, so you can see This is the session I have taken on this HITL. Even I already showed you the real example of HITL. Please try to go ahead. You will try to understand. Okay. Now see guys, this is the updated architecture. So if you can see this architecture. So first of all, whatever user input is giving, that means the same architecture I just let's say upgraded and added. These are the functionality, okay, as in advanced tools. So as you can see, first of all, user will give the input, and this input, instead of directly passing to our agents, so what we are doing, we are first of all checking these inputs. Okay, we are applying the guardrails operation here, and you know what guardrail does. Okay, it basically validates the user input and it checks whether this is relevance or it is safe or not. Okay, for this particular let's say application, if it is having any kinds of violation, if it is having any kinds of harmful content, or let's say any kinds of sexual content, that time this request would be blocked. Okay, directly we will block this request. We'll tell this is not let's say the input, this is not actually, let's say, appropriate for this particular agent. Okay, so every application, if I show you right now in ChatGPT also, so if you are trying to give any kinds of harmful or violation related prompt, it will directly block your request. So let me show you. So let's say I'll give how to make bomb. Okay, so let's say this is a kinds of this is actually breaking the violation. Okay, this is basically harmful. We can consider this prompt is a harmful. So as you can see, this prompt is basically harmful prompt, so that's why this will be blocked. Yeah, you can see it is telling I can't help you with the instruction for making bomb or other explosive weapon. That means it is directly blocking your request. It is not giving you the step-by-step procedure like how to make the bomb. Okay, so every real-time application is having these kinds of guardrails features. So now we'll try to add these guardrails inside our agents also. Okay, so if my user input is basically safe, it is relevance, okay, it is completely fine for the agent, that time we'll try to pass this request, we'll try to send it to the agent, otherwise we'll try to block this request. Okay, so this is the new things we'll try to add, and basically we'll utilize the guardrails here. And in this video guys, I already told you we are having different types of guardrails are available. Okay, if you see that tutorial, you will see that I already discussed like different types of guardrails. So as you can see, we are having two approaches to implement a guardrails. One is the deterministic approach, one is the model based approach. Okay, so in this development I'm going to use the model based approach, because I told you model based approach is like more robust and more efficient, because here we'll utilize one large language model and we can basically apply these guardrails in a more robust way, so there won't be any kinds of possibility it will miss any kinds of violation related input. Okay, that's why I'm going to utilize this model based guardrails approach. Okay, and this link would be given in the description. The entire playlist link would be given in the description. From there, please try to check this playlist. Okay, if you are not familiar with any kinds of concept. Then once this guardrails implementation is done, then I'll try to add another things, which is nothing but our supervisor agent. Okay, now why the supervisor agent is required? See, if you are adding the supervisor agent, that means what will happen, instead of running all of the agents, as you can see, we are having some specialized AI agents. Okay, because this is a multi-agent app, and for the multi-agent operation, that means we are doing different tasks. Let's say for the trip plan, we are using flight agent, hotel agent, weather agent. Then in this part 3, I'm going to add another agent, which is nothing but our budget agent. Okay, this budget agent will basically analyze the budget, estimated cost, okay, to a location, each and everything it will provide. Then the itinerary agent and the final agents. Okay, so these are the things our specialized AI agents. So sometimes it's not like that we have to run all of the agents. Let's say user is asking, so let's say user is give the prompt like that, find the best hotels in this particular country. Okay, let's say country X. So that time it's not necessary to run the flight agent, weather agent, okay, or let's say itinerary agent. That time hotel agent and budget agent is fine, because it will only look for the best hotel in that particular country, and to book this hotel, actually what are the budgets are required for this agent should be running. That means if I run two agent, I don't need to run like these are the agent as well, the remaining agent. So if you're running the remaining agents, what is happening at the end, you are increasing the LLM cost, right? Because every let's say agents are using some kinds of LLM, right? Or let's say some kinds of API request. So instead of hitting all of the agents, okay, as a sequential order, what we have to do, first of all, we have to select with the help of the supervisor agent, that means which agent is responsible for this particular query. Okay, so we'll try to select those agents and we'll only execute those agents which is needed for that particular query. Okay, I hope you get it. What is the work of this supervisor agent? Okay, so as you can see, it understands the request and decides which agents are needed. So it will basically select all of the agents whichever is required. So no more manual workflow definition. That means you don't need to execute the workflow from the beginning. Okay, so based on the user request, it will understand what the agents are required. It will only select those agents and it will execute. So sometimes, let's say for a user query, it needs all of the agents to be run. Okay, that time, yeah, definitely it will select all of the agent and it will run that. Let's say user is asking plan a complete trip, let's say from country A to B. That time I need flight information, I need hotel information, I need weather information, I need budget information, I need itinerary information. That means all of the information I need. That time all of the agent would be running in a sequential order. Okay, but whenever user is asking specific, let's say information, let's say budget information, hotel information, or flight information, that time that agent should be only running. This is the work of the supervised agent, and we'll be adding the supervisor agent inside our part 3 development. Okay, I hope you got it, guys. Now all of the code, all of the, let's say, architecture is same. Okay, almost same, whatever we have implemented previously. Like we will have the state memory. Okay, we'll try to upgrade the state memory, and for the state management, we'll be using PostgreSQL database. We'll try to save all of the checkpoint, all of the, let's say, conversation in the Postgres database. Okay, and one additional things we'll try to add here, one new things we'll try to add here, which is the human in the loop. Okay, now as I already told you, we'll try to add this HITL. Why HITL is required? Let's say whenever it will prepare a itinerary for me, or let's say final draft for me for the entire travel plan, first of all, instead of showing you the final, let's say, draft plan, or let's say final plan, it will ask for a review. Let's say it will ask permission from human whether this draft is fine or not, whether this plan is fine or not, whether you need any change or not in this particular plan. Then human will review that. If human, let's say, approves this particular plan, that time what will happen? It will generate the final, let's say, travel plan for you. Okay, it will give you the final PDF file for you. But if you need still some changes, so what you can do, you can request the changes here. That means you can give your feedback. Let's say what are the additional things you need to add inside this particular plan. Okay, so it will again go to this agent, and again it will try to add those are the information. Again it will prepare a draft for you, and again if you approve that, it will be finalizing that particular PDF. Okay, I think you are getting. That means instead of directly like saving the PDF file, instead of directly, let's say, giving the travel plan, okay, directly finalizing the travel plan, we'll first of all ask for the human verification. That means human in the loop will try to apply. If human approves this particular content, we'll try to finalize that. Otherwise, we'll again do the changes. We'll send the feedback to the agents. Agents will try to modify. Again, we'll try to finalize that particular output. Okay, so this is what we'll try to add. That means what is the new things in the part 3? As you can see, first of all, we'll try to add the input guardrails. We'll try to validate every request, ensure safety and relevance, block invalid or harmful request. Okay, then second, we'll try to add the supervisor agent, so it will understand the user intent, select the required agent for that. Okay, and no manual workflow definitions. Okay, that means we'll not execute all the workflows as a sequential order. Then the third things, we'll try to add the human in the loop. That means HITL. So here we'll try to basically understand the here we'll try to ask the user reviews. Okay, for the itinerary, that means the travel plan. If user approves the request, we'll try to finalize that. Otherwise, we'll ask for the review. And if user gives any kinds of review or request to change, we'll try to change those are the things, okay, inside the draft file, and we'll try to finalize that particular output and ensures high quality, trustworthy results. Okay, so for this, we'll try to add these are the 3 new things inside our AI agents. Okay, and that's how, guys, we'll try to learn all of the amazing, all of the, let's say, most important concept inside AI agents implementation, because many people are worried about like how we can add these are the things like supervisor agents, guardrails, okay, or HITL in the multi-agent system. So I think this project will cover each and everything. Okay, that's why I'm implementing step by step so that you can understand. Okay, if I'm implementing without MCP, so what would be the problem? If I'm implementing with MCP, so what would be the benefit? If I'm not adding these are the concepts, so what would be the disadvantage? And if I'm adding these are the concepts, so what would be the advantage? Okay, now you have enough amount of understanding. Okay, I hope you clear, guys. Now what I'm going to do, guys, I'm going to start the coding. So for this, I'm going to utilize my previous code only. That means the last code I have developed. You can see this is the MCP code. That means the architecture to this architecture. So we have already completed this coding. So I'm going to utilize the same coding. I'm going to copy paste most of the code from here, and I'm going to add those new changes here. Okay, that means the supervisor agent, guardrails, as well as the HITL features. Okay, yeah. So instead of like changing inside the code, so maybe what I can do, I can create a new repository and I'll copy paste most of the code from here only. Okay, that means all of the MCP related code, client, these are the backend file would be same as it is. Then I'll do modification in the HTML and CSS little bit just to change on the user interface, and I'm going to change inside the backend.py file. Okay, because in the backend.py file we have to add the guardrails, we have to add the supervisor agents as well as the HITL functionality. Okay, so this code I will just keep it as it is just for your reference, and I'm going to create a new repository here. Okay, so I'm going to open my GitHub and let's create a new repo here. So I'm going to name this repository. I'm going to name this repository as multi agent system using let's say MCP, then then supervisor, MCP, supervisor, guardrails, and human in the loop. Okay, or I can make it as HITL. Okay, so let's say this is my repo name, or you can give any other name, it's up to you. Let me check whether this name is good or not. Multi-agent system using MCP. Okay, maybe I can add LangGraph. Okay, LangGraph, MCP, supervisor, guardrails, as well as the HITL. Okay, you can even see the architecture. Yeah, I think this is good. This is good. Now I'll try to create this repo. So for this, let's make it as public, and I'll add the readme file here. Okay, and I'll also add the git ignore. I'll take the Python, and let's add the license. Let's take this Apache license and let's create the repository here. Okay, and I'm going to use the same render PostgreSQL server. I think you remember we already created a PostgreSQL server, okay, in the render. So we'll try to utilize the same server here. Okay, we're not going to create a new one here. So now let's clone this repository. I'll just click on code, copy this link address, and open up my folder. So here what I can do, maybe I can clone it here. I'll open up my terminal. Okay, so let's close this terminal. This is not required. Yeah. Now here, let's clone it. Just write git clone and paste this URL and execute. Okay, so as you can see, this is done. Now what I'm going to do, I'm going to go inside this folder. The folder name is multi-agent system. So I'm just going to write cd, that means change directory, multi-agent system using LangGraph, MCP, supervisor, and guardrails, HITL. That means now I'm inside this particular folder. Now inside that, I'm going to open up my Visual Code Studio. So simply you can open up your Anaconda prompt and just write, you can open up your Anaconda prompt and you just need to write code space dot. Okay, it will open up your Visual Code Studio here. So this is my Visual Code Studio. Let me zoom and let's close this window. Now I'll clear and make sure you are activating the environment. So what was my environment? So conda env list. So the environment name was, I think, travel. Okay, this was the environment. I'll just try to activate. So conda activate travel. Okay, yeah. Now most of the code I will try to copy paste from my previous code. As you can see, from here only I'll try to copy paste all of the code whichever I need, and on top of this I'll try to add the new upgrade. Okay, that means this new changes. Uh, yeah, in this architecture, whatever new change I have added, okay, we'll try to upgrade that. So first of all, let's add the readme content here. So we'll try to or as of now it's fine, I'll try to upgrade this readme later on, but let me add the requirement file here first of all. So I'm copy pasting, okay, from my previous code base only. So this is the requirement.txt and these are the requirements guys you need. Okay, I already explained which requirements you need for what kinds of tasks. Okay, I haven't added the version for the certify, so what I can do, maybe I can check the version. I'll just write pip list. So certify. So this is the certify and this is the version. Let's copy this version and add it here. So make sure you add all of the version for all the package. Otherwise, if you are running this project after let's say 1 or 2 months, there is a possibility this package would be updated. And especially in Agentic AI, this is like most frequent update. So that's why adding version is super important. Once it is done, so make sure these are the packages already installed. You can either verify. So for this, you can run this command pip install -r requirement.txt. So I think it is already satisfied for me. Okay, it's completely fine. Now, what I need this static and template folder. Let's copy that as it is. Static and template. So this is the static and this is the template. I'll just try to copy and here I'm going to paste. Okay, then apart from that, I need this. See, these tools I don't need anymore because I'm not using this tools tools folder. I already created the MCP server. That's why this is not required. So I'm going to not copy this one. Instead of that, whatever Docker, then .env, then app.py, backend file, custom MCP server, Docker file, MCP client. Okay. Yeah, I think these are the files are required. And apart from this, these are the file related testing. Okay. I only tested the MCP server. That's why I created those files. Okay. But I don't need that as of now. So I'll just try to copy them. Copy and paste it here only. Okay. So yeah, as of now, these are the files I need from my previous code. Now we'll try to do the modification here one by one. Okay. So first of all, make sure you add all of the environment variable, the upgraded environment variable. Make sure you have the Grok API key, Aviation Stack API key. Even I already showed you how to collect all of the API key. Okay. And this is already up to date for me. So I'm going to use this as it is. Okay. So I'm going to use this as it is. Perfect. So now what I'm going to do, I'm going to simply open my backend file, because in the backend file I have to do the change. Now let's upgrade my code. Okay. Now these are the import. It's completely fine. There should not be any kinds of change. I'll just keep it as it is. So let me remove this at the line, because this is, I'm not using anymore this comment. And instead of importing like that, maybe you can import like that. Inside this bracket, you can import them one by one. So if you import like that, the visibility should be good. Okay, now you can see, you can read all of the import in a single line itself. Okay, fine. Now this function I will also keep as it is. There should not be any kinds of change in this function, because this function returns our database URL by adding this SSL mode is equal to required. And apart from that, this grok API key is fine. I'm not going to change the thing, this thing. LLM definition, this is also going to be same. Okay, I'm not going to change it. Now let's come to the state. Okay, now this state should be changed. Okay, this state we have to change, because right now, if you see my architecture, we are adding some more functionality like the guardrails, okay, as well as the supervisor agents, as well as the HITL features. Okay, so for this, definitely I need some state variable. Okay, so let's try to add the state variable. Now see this I think VS Code I can close, because this is my old VS Code. Now this is my new one. Okay, now here I'm going to add all of the upgraded state I have. Let me show you. So this is my state, guys. Okay, I have to import one library, which is Annie. Let's import that library from typing. I think it is available inside typing. Yeah, typing, annotated. I'll import Annie. Now this is fine. Now see, guys, this is the upgraded state we will be using for this project. So these are the same we are using from the previous one only. That means message, user query. Okay, so whatever message will try to do the conversation, and whatever agent will try to return me, it will store actually inside the message variable. And that's why you are using reducer function. Instead of replacing, it will add, continuously add inside a list. Okay, then user query, whatever user query user is giving, we'll try to add here. Then you can see for the guardrails and supervisor agent. Sorry, for the guardrails actually operation and supervisor agents, we are adding some state variable here. That means guardrails allowed. This should be Boolean type. That means if my guardrails will let's say accept this request, this parameter would be true. And if it is not accepting, this would be false. Then guardrails reason, it will also tell you the reason why it has rejected. Okay, and why it has accepted. This reason should be also saved here. And selected agent. That means I told you this supervisor will select the agent based on the user query. It will understand the user query, user intent. Based on that, it will select the agent, whatever agents would be required for that particular prompt. So let's say it has only selected flight agent, or let's say weather agent and itinerary agent. That time this 3 agent would be saved here. That means in the selected agent, whatever agent my supervisor agent will select, it will save here. That's why it's a list type. So what is this strip constraint here? See this is nothing but, so whenever user is giving a prompt, let's say plan a trip from country A to B under 2 lakhs taka. Okay, so inside this prompt, actually there are some information we have to extract if I want to understand the user intent. Let's say first of all, I can extract the destination, like where he or she needs to visit. Then the origin, from where actually they will be visiting to that particular place. Let's say user is giving India to Dubai, so origin should be India and destination should be Dubai. Then the duration, let's say user is giving 2-month plan, so this is the duration. Then the budget, okay, let's say budget is 2 lakhs, so we have to extract that particular budget. So this is called actually trip constraints. So we'll try to extract, these are the constraint from the user prompt, and we'll try to save inside this strip constraint variable. Basically this is going to be a dictionary type, because here we are extracting multiple entity like destination, origin, duration, okay, budget. These are the thing. So that's why we'll try to take a dictionary type, and this thing will use for whenever we'll generate the itinerary. That time we'll try to provide these are the information, so that my agent will have better understanding the user entity. Okay, sorry, user actually intent. I hope you get it. Then the supervisor reasoning. Supervisor reasoning means, let's say this supervisor will select the agents. Okay, let's say it will use based on the user prompt. Let's say it has selected flight agent, hotel agent, and itinerary agent. Now, why it has selected flight agent, hotel agent, and itinerary agent based on the user prompt, it will explain you as well. Okay, so those explanation will try to save inside supervisor reasoning. Okay, and that's why we have taken the string type. Then the original specification, that means the flight result, hotel result, weather, itinerary, that means the previous whatever state we are using, we are copying as it is. Okay, there is no change. Then for the budget agent, we have added some more variable here, that means budget result. So what is the budget result we'll be getting from the budget agent itself, will try to save the information here. Then the approval request, this is for the HITL, that means whenever user will approve any request, so basically it will come to here, and approval request, this is a string because here user it will save the information. Let's say user has approved the request. Okay, and this is another variable I'm taking, approved. This is boolean type. Basically this will save the information as true or false. That means if user approved the request, it will be true, otherwise it would be false. Then the human feedback, let's say if user has rejected the request. Okay, that means the draft it has planned, user has requested, user has, let's say, rejected. Why he has rejected and what is the feedback he wants to or she wants to give, whatever, let's say, feedback they're putting, will try to save inside this particular state variable. Then whatever final response we'll try to get from my final agent, we'll try to store it here. And the LLM calls, how many times we are calling the LLM, so we'll try to save those in the, those are the information here only. That's why this is integer type. So guys, now I hope you got it. Why we have taken these are the state variable for this particular development. Okay, I hope it is clear. Now the next thing, guys, we'll try to we'll try to add some more functionality. So I'll remove this code. This is I'm not using anymore. Yeah, so here only I can show you the upgrade. Now see, some helper function and helper things are required. Let me show you. So these are the helper function and helper variables are required. Let me show you. So see, so first of all, let me import the JSON. The JSON is required. So here I'm going to import the JSON as well. Now if I show you, see, so here you can see, first of all, we are taking a Python set. Inside this set, we are adding all of our known agents. Okay, known agent means our primary agents. That means these are the agents. Okay, our specialized agents, that means flight agent, hotel agent, weather agent, budget agent. Okay, whatever agents we are using, we're adding all of the name. Okay, because these are the agent I'm using inside this development. And why I have taken as a set, because I don't want to take any duplicates, let's say object duplicate agents. Let's say flight agent I have mentioned 2 times. So if I'm taking the sets, it will only return you 1 time. Okay, that's why I have taken a sets. So that's why inside this particular variable I have written sets. I have written flight agent, hotel agent, weather agent, budget agent, and itinerary agents. Okay, I need it later on. I'll tell you. Okay, whenever I need this particular sets, okay, I'll tell you that time. Then the agent order. Okay, what is the order of this agent right now? You can see this is the order. First of all, flight agent, then hotel agent, then weather agent, then budget agent, then itinerary agent. As you can see, this is the order: flight agent, hotel agent, weather agent, budget agent, itinerary agent. Okay, this is the order we are following. Then after that, we have taken a function. The function name is LLM_text. Okay, so what it does, instead of calling this LLM, invoking this LLM again and again, I have created a function, and whenever I need to call any LLM, I'll call this function only. Okay, LLM text. So basically here I'll try to pass the system prompt as well as this user prompt. It will invoke the LLM and it will give the LLM response. Because if you have seen the development, this multi-agent development, I'm calling the LLM multiple time, and everywhere I'm calling with the LLM object, right? So instead of again and again calling that, maybe I can write a function, and whenever I need it, I'll just try to call this function and I'll give my system prompt and user prompt. It will give me the response. Okay, that's why I've created a separate function for that. Then the next thing, I have created another utility function called JSON from LLM. That means whatever LLM returns as an output, okay, I'm converting to the JSON format. Okay, this is the function I have written for that. So first of all, what I'm doing, I'm starting this curly bracket and the end curly bracket. Then I'm checking, okay, whatever, let's say I have inside this starting and end curly bracket, I'm taking those data and I'm converting to the JSON format. Okay, so this is the simple function I have written for the whatever LLM response I'll get, I'll just try to convert as a JSON format. Why JSON format is required? Because JSON communication is very easy. It would be very easy for agent to agent. Let's say this agent has written something. I'll just try to convert this output as a JSON format. Then I'll try to pass to the next agent. Okay, and this agent will try to get that input. And if it is a JSON format, it would be easy for the communication. That's why we are converting to the JSON format. Then I have taken an empty constraint. I think remember I told you about the constraint type constraint variable. So basically this will extract some of the keyword from the user prompt. Let's say it will extract destination, origin, duration, budget, travel styles, special preferences. Okay, so these are the information it will extract from the user query, and those information we'll try to save inside the state variable. Let's say for the first time, if user is not giving anything, that time I'll try to pass this empty constraint. That means there should not be any kinds of value, only the variable I'll try to pass. That's why this empty constraint function I have created. Okay, so these are some utility related function I need. Now we'll try to add my first agent here, which is nothing but supervisor agent, and we'll also add the input guardrails functionality here. Okay, so in a single function itself, I'll try to add the input guardrails as well as the supervisor agent, because if you just think about, whenever user will give any input, first of all it will go to the input guardrails, and if input guardrails is let's say accepting that time of supervisor agent would be triggered, otherwise it will be block the request. That's why these things and these things we have to write in a single function itself. Okay, now let's try to work on this code. Okay, now let's try to work on the supervisor agent as well as the guardrails part. So for this, what I'm going to do, guys, I'm going to write a single function, and inside that I'm going to implement these guardrails as well as the supervisor agent. Okay, and you know what would be the task of guardrails? It will basically check the input, it will check the relevance, FT, etc. And if it found like everything is fine or this is safe, that time it will pass that request, it will send it to the supervisor agent. Then supervisor agent will try to select whatever agents should running for that particular task. Okay, and if it founds any kinds of violation or harmful content in the user input, it will try to block the request. Okay, this is what we have to run. Right, so let me show you guys. I already prepared this function, and I already told you here we'll be using model based guardrails instead of the deterministic one. So let me show you. So this is the function, guys, I have prepared. So this is the function, guys. Yeah, it's a very simple function. So as you can see here, we are handling the supervisor agent as well as the input guardrails. So this is the function name, supervisor agent. This will take the state. Okay, that is the travel state, and from the state it is taking the query. And also I'm getting the LLM cost. Like I want to update how many times we are calling the LLM. Okay, we want to upgrade that. I think you know in my part 2 architecture development, that time I told you, okay, about this part. And this is what our guardrails prompt, guys. Okay, so here I told you we'll be using this model based guardrails. Okay, and if you check this video, I already covered this model based guardrails in practical as well. So there we have to use a large language model, and for this we need to write a prompt. Okay, so this is the prompt we are writing. So basically determine whether the following requests belong to travel planning or travel information. Valid request can include destinations, flight, hotels, weather, budget, visas, transportation, sightseeing, food, packing, or itineraries. Okay, block clearly unrelated request, and request asking for the harmful or illegal instructions. Do not block a valid travel request merely because some details are missing. Okay, return strictly JSON only. So I'm telling you just need to return a JSON format. Okay, so that's why sometimes whatever response you will be getting from the LLM, it looks like a JSON, but it is not a JSON. It's a kind of a string output it will give you, okay? And to make it JSON, guys, I already told you we'll be using this function, okay? JSON from LLM. That means here, if you pass your LLM output, it will convert it to the JSON format. That's why I written that function, okay? So now I think you are getting, this is the model-based guardrails we are implementing here. So we are giving a strict prompt here. From the user input, it will automatically understand whether this prompt is related to travel or any kinds of travel planning or not. If it is not, if it is having a harmful or irrelevant informations, that time it will block that particular request, okay? So you can see in the JSON only, I'm only sending two things. One is the allowed, that means if it is if the user request is allowed or not, and the reason, okay? If it is allowed, so what is the reason, and if it is not allowed, what is the reason, okay? These two things every time this guardrails will return, okay? And here we are passing the user query, and here we are writing that code. We are writing the LLM call in the try except block. As you can see, we are calling the LLM text, that means this one. I think, remember, this is the function. This function takes the system prompt and user prompt, and it will invoke the LLM and it will give you the response. So we are using this function for calling the LLM. As you can see, here we are passing the system prompt. This is the system prompt. You are the input guardrails for the travel planning application, and return strict only JSON output. And this is the this is our user prompt, okay? That means the guardrails prompt we are sending here in this function, and this function will trigger the LLM, okay? And we already initialized the LLM. I think you remember. Here is the LLM. We are using this Grok LLM, okay? And you know how we have configured the Grok. This part I already covered. We are using Llama 3.37 billion versatile model. Now, if I come here, yeah, here only. Okay, so this will give you the response. So now we are sending this response to our JSON from LLM function. That means this function, so that it will convert that output to the JSON format. Now, once we got the JSON output, now we are checking this allowed variable. If it is true, okay, that time this allowed would be true, okay? Otherwise it would be false, okay? Now, guardrails region, I'm also extracting the guardrails region. That means it will return you two things, allowed and reason, okay? So both we are extracting from the JSON. Then we are upgrading the LLM call. That means we have called this LLM. That's why we are doing the plus operation. That means a one-time LLM call has been updated. Then exception, if let's say this fails, okay, it will raise the exception that time. And it's recommended to use try except block inside your development always, okay, if you're using any third-party API call and all. So here we are calling the LLM, so definitely this is a third-party Grok provider we're using. Sometimes there is a possibility your API key would be let's say limit over, or let's say the server would be down. So that's why we are handling in the try except block. Okay, now we are checking if not allowed. That means if this particular let's say variable is false, let's say my guardrails has rejected that prompt, that time simply we'll just tell this is the message, okay? This is the reason. TripMate AI can only help you with travel planning request. Please ask about a destination, flight hotels, and budget or itinerary. You don't need to ask any kinds of illegal questions, okay? This is the message we'll try to show, and we'll try to return these things, okay? Like guardrails allowed, guardrails region, selected agents, okay? These are the variable we'll just try to return. Okay, I hope you got it. And if it is allowed, okay, if it is allowed, that this else condition will run. This else condition will run. Else condition, we are hitting the supervisor agent that time. Okay, that means if this condition is passed, that means my guardrails is passed, that time we'll try to run the supervisor agent. And if it is fail, we'll try to show this message, actually, this message, and we'll return these are the things. Okay, I hope you get it, guys. And in this return, actually, we'll see that guardrails block your request. It will give you the message, and some other variable actually we are returning as well here. Okay, simple things. Now in the else condition, as you can see, we are preparing the supervisor prompt. That means for the supervisor agent, we need to prepare a prompt. So here we are preparing the prompt. So you are a supervisor of multi-agent travel planning system. Choose only the specialized agent needed for the request, available agent. So you're giving all of the available agent, flight agent, hotel agent, weather agent, budget agent. Then we have itinerary agent, okay? And each and every agent, what it does, I have written the detailed description of that. And here we're telling return strictly JSON only using the schema. That means it should return the selected agent. Let's say it has selected flight agent, hotel agent, weather agent. Okay, whatever agent it will select, basically it will give the list. Then trip constant. So whatever user is giving the input, from the input itself it will also extract the constant like destination, origin, duration, budget, travel style, special preferences. Okay, these are the things it will also return. And here we are giving the user query. Then again we are calling the LLM, and again we are doing inside try except block. We are using this LLM text function. Okay, we are giving the system message as well as the supervisor prompt, and whatever output we are getting, we are passing to the JSON from LLM. That means it will return you the JSON format, and from that itself I'm extracting the selected agent. That means which agent it has selected. Then we are also selecting this see one more thing I want to tell you. I think you remember I told you about the agent order. This list we have written, right? So basically we are maintaining the order here. If I show you, see whatever agent it has selected, it's completely fine, but there is a possibility there should not be order. Let's say before flight agent it has given you hotel agent, so I have to order that, because after flight agent hotel agent should become. Okay, because if I'm not getting the flight, so hotel what I will do, right? So that's why it should be a sequence, and this sequence order we are maintaining here. Okay, we are maintaining here. So basically with this list actually we are maintaining the order. As you can see, selected agents, we are maintaining the order here in this code. That basically we are whatever agent it is selected, it's completely fine, but we are maintaining the order, agent order. Okay, I think you got it. Then here I have written one condition. If itinerary agent is not available in selected agent, that time I'm adding this itinerary agent manually here. Okay, why I'm adding that? Because see, you have to remember that whatever you do, it's completely fine. Flight agent, hotel agent, weather agent is completely fine. Okay, but at the last you need this itinerary agent, because itinerary will try to plan for everything, right? Whether let's say you have executed flight agent, hotel agent, weather agent, it doesn't matter. All of the information will go to the itinerary agent, and itinerary agent will try to prepare the plan for you. So every time itinerary agent should be there. Whether it is selecting only flight agent, hotel agent, it doesn't matter, but itinerary agent should be there to generate the plan. That's why if itinerary agent is not found in the selected agent, I am adding the itinerary agent manually. Okay, I hope you got it. And the constant, okay, this constant. So initially I'm defining this constant as an empty constant. I think you remember we have defined an empty constant. Okay, if my model does hasn't extracted anything, that should be empty initially. Okay, then we are taking the trip constant from the LLM. Whatever, let's say JSON format we are getting from the LLM, we are extracting the trip constant, because you remember we are also extracting these are the information from the user query. Okay, and we are upgrading it here. Then after that we are checking if this is instance parse constant. We are basically convert it to the dictionary, and we are upgrading the constants. Okay, so basically what is happening, see this constant we have created, right? This is initially it is empty, but whenever we are able to extract from the user query, that time we are upgrading that. Okay, and this is a dictionary format, that's why converting to the dictionary. That's it. Okay, then we are getting the reasoning. Okay, reasoning means why it has, let's say, taken these are the agent. Okay, for that particular user query. So I think remember this reasoning we have already taken this state. Supervisor reasoning. Okay, so basically here it will explain why it has selected those agent. Okay, for the user query, let's say you have given a query, a planet trip from A to B country, and prepared the hotel for me. Okay, so let's say it has selected flight agent, hotel agent. Let's say it didn't selected the weather agent, because user are not interested knowing the weather. Okay, and the budget agent. Now it will explain you why it has rejected the weather agent. Okay, what is the condition? This is called reasoning. Okay, this reasoning, this information actually it will save here, so that user can see why it didn't selected the weather agent. Okay, so to explain is required why it is not selecting the this particular agent. Okay, so for this explanation we are using that, and from here only we are getting the reasoning. And if any exception is occurring, we are raising the exception. In the exception you can see supervisor parsing failed, so original full travel workflow was selected as the safe fallback. Okay, so we are raising the exception. Then we are returning the variable. Okay, that means these are the variable: guardrails allowed, guardrails reason, selected agent, strip constant. Okay, supervisor reasoning, message, and LLM calls. These are the things we are returning. So yes, guys, this is what our supervisor as well as the guardrails. I hope you get it. And here we are using the model-based guardrails, okay, instead of using deterministic one. There are some other guardrails types are also available. I told you, okay, you can check that video, and as per your requirement, you can use that type of guardrails. Okay, yeah. Now, we'll try to write another function. Basically, this function will return you the guardrails block response. So instead of extracting from here, I think I can write a function. So this is the function guardrails blocked agent. This will take the state, and from the state itself, it will take the final response. Okay, and guardrails region. Okay, so then basically, see, this is the region. Okay, why your guardrails blocked the request? So basically, this will give you the reason. So here we're getting the final reason, and this is the message. Okay, AI message, and this request was blocked by the travel input guardrails. That means if, let's say, guardrails guardrails reason, it is, let's say, it is, let's say, it is not nothing. Okay, if this reason is nothing, that time definitely uh, this request was blocked. Okay, that time actually we are sending this message. Okay, this request was blocked by the travel input guardrails. Okay, so this is our reason. So basically here this function will return you if your guardrails block your request, okay, or accept your request, it will give you the reason. Okay, and we are only focusing on the block agent. Okay, guardrails block agent, that means it will, if it is blocking your request, that time it will give you the reason that time. Okay, so this is the function we have written. Now we'll be working on the flight agent. Now see, this is our flight agent. That means this agent, and this agent will remain same as it is. We are not going to change anything. Okay, so you can see this is same as it is. No need to change anything. Let me check everything is fine or not. So this is fine. Okay, I don't need to change anything. But slight upgrade maybe I can do. Slight upgrade means I will add the try except block here, so that this will look good. So this is our flight agent as it is. Okay, nothing changed. You can see I'm using the same prompt, same the MCP server. Okay, and we're hitting the LLM, and whatever response we are getting, we're returning it. And here we are just returning these are the things. Okay, this is the major minor update I have only done in this function. Otherwise everything is same. Okay, now after flight agent you have to work on the hotel agent. Now hotel agent will also remain same. There should not be any change, but again I'll just try to upgrade the return. Okay, this return variable. So this is our hotel. You can see we're taking the query, we are running the MCP server, and we are returning these are the information. Okay, now after hotel you have to upgrade the weather agent. So let's work on the weather agent. Again, this will remain same as it is, only I will upgrade the return code. So this is our weather agent. Okay, as you can see, we are using the same MCP server, only I just need to do a slight modification in the MCP server. So if I open my, I think remember custom weather MCP server we created, let's open it up. And here you remember, I think I created a sorry, this is our custom MCP server, right, for the weather, get the real-time weather information, and this thing we're using inside MCP client. Now if I open the MCP client, I think remember we added a path, because this is my local MCP server, and this file path you have to mention here. Okay, the complete path. Now what you can do, because I moved my project in a different folder right now, so I have to give that particular path. So I'll copy that path. So I'll just click here and copy path and mention it here. Okay, so this is our new path right now, and here my custom weather MCP server file is present. Okay, make sure you are giving your path location, not my path location. Okay, yeah, so this is the slight update you have to do. Now everything will remain as it is. I'll close this file. Yeah, now I think everything is good. Yeah, so this is our weather agent, and this is also ready. Okay, now we'll be creating the budget agent. Okay, this is the new agent. Now we'll try to add inside our code before the itinerary agent. So let's try to add. So this is the budget agent. Let me show you. So basically it will prepare the budget for the trip. So this is the budget agent, guys. budget agent. This is our new specialized. So we are giving the prompt, analyze whether this trip is realistic for the user budget or not, user query, tube constraint we are giving, flight result we are giving, hotel result we are giving, weather result we are giving, and it will return you estimated cost categories, budget risk areas, money saving suggestions, overall feasibility. Okay, and if exact, live, precise are unavailable, clearly label, estimated, and approximate. Okay, then we are hitting the large language model, and whatever response we are getting, we are returning that. So this is our budget agent. Okay, now this agent is also ready. Now we'll try to work on the itinerary agents. Now let's try to use our same itinerary agents before we have created. Only the budget agent result should be added here. So let me show you the updated function. So this is the updated function. Okay, I have to replace this. So this is our updated function, itinerary agent. So as you can see, all the code are same, only we have added this budget result here. Okay, and all the codes are same. Okay, and one more thing we have to add inside this itinerary agent, which is nothing but our approval request. Okay, so whenever we are hitting the large language model, it's completely fine, but here we are taking the approval request. Okay, now in the approval request, we are telling please review the generated draft itinerary, approve it, or create the final polish plan, or provide a feedback for revision. Okay, because see what happens whenever it will plan for the trip, right? Let's say using your flight information, hotel information, weather information, budget information, everything it will utilize and create the itinerary. Okay, that means the entire plan. So before generating the final plan, first of all, I will apply this human in the loop. That means it will ask for the human approval. Okay, if human approve that, then it will run the final agent to prepare the final draft. Okay, and if user needs some modification, then it will again go to the agents, it will do the changes, then it will return that. So for this, actually I'm using this approval request. We are telling please review the generated draft itinerary and approve it, create the final polish plan. Okay, so we are asking the human, we'll ask the human just try to review and accept it, or and if you need any change, you just do let us know, we'll try to upgrade that. Okay, so for this additional operation we just added inside our itinerary agents. Okay, that's it. Now I'll tell you how to create this human in the loop function. Okay, so I already created, let me show you. See, before final agent we have to create this human in the loop. So this is the human in the loop, let me show you. This is our human in the loop, that means HITL function. Okay, and for this, you remember we have to import interrupt from LangGraph. Okay, so let's try to import that. I'll just try to import this interrupt and command from LangGraph. And definitely for this you need understanding on the HITL, and definitely you have to refer my playlist, guys, because this thing I'm not going to explain again and again. I already covered this part. Okay, this topic. So from LangGraph we are importing command and interrupt. Okay, now let's go to the function human in the loop, and let me explain the code I have written here. Now you can see we are interrupting the execution. I think you know human in the loop will interrupt the execution. It will pause the execution unless and until human gives any approval. Okay, so as you can see we are interrupting with the help of interrupt function. Then we are taking the question, do we approve this itinerary? If user approves that, then it will take that particular approved operation, it will upgrade the state. Okay, then we're also taking the draft itinerary. We are taking the approval request from the user, selected agents. Okay, whatever selected agents we have currently in the state. Then supervisor reasoning, what is the reasoning right now supervisor having, we are also taking that data. Then expected response. Okay, if it is true, and feedback, original version feedback. Okay, so we are returning this particular things as expected response. Okay, and if user needs any modification, that time we'll accept the modification. Now we are taking the user input, like whether user has approved or not. Okay, based on the approved variable we'll try to do the further step. Then the human feedback also we are taking. So whatever feedback user will give, okay, there would be a box, input box, there user will write what are the upgrade they need, they will write the human feedback here. Then we'll try to return, these are the data, like approved, human feedback, and message. Okay, these are the data we'll try to return. Okay, based on that, actually my next agent will run, whether it will run the final agent or again it will go to the previous agent to upgrade the existing draft plan. Okay, so I think you get it. Now let me write my final agent. Okay, no, this is the final agent. So this is the final agent we already have. Let's try to modify. So this is our final agents right now, guys. As you can see, final agents. So you are taking the approve from the state. Okay, we are taking if this approve is false, that time we are uh, reviewing the instruction. The user approved the draft. Uh, Sorry, if it is true, that means it will tell the user approved the draft. Please its decision while polished it. Else review the instruction. The user requested to revision. Apply this feedback carefully. Okay, then whatever user feedback given, we'll try to send it here. Okay, improve the draft before finalizing it. Then we are passing it to the final agent. We are giving the human review. Okay, and we are giving the prompt generate the final travel response for the user. So we are executing this human review, user request. Okay, and then user query, supervisor constraint, flight information, hotel information, weather, budget analysis, then draft itinerary. Okay, the previous itinerary it has generated. Then we are finally generating this final output. Okay, with trip summary, flight information, hotel suggestion, weather information, day by day itinerary, estimated budget, final recommendation, and some important construction I have given. Okay, and we are hitting the large language model again. Okay, and the result we are getting, we are again returning that result. That means the final response message as well as the LLM call we are upgrading. Okay, I hope you get it. This is the final agent we have created. That means overall the final agent, right? We have created that. So here I have been mentioned that final agent here because I know that, I think you know, because previously I already added this final agent. Okay, so I forget to add here, but I think you remember. We need to execute this final agent to get the final response. Okay, it's done. So yes, our all the agents are done. Now we have to build the graph. But before building the graph, I need some additional utility. Let me show you. These are the utility I need. Okay, these are the utility you need. So here basically I have taken a dictionary called route map. So this route map is having this uh, like node name. Okay, so whatever node will try to create for this graph, right? So let's say guardrails block would be another node. Then flight agent would be node, hotel agent should be another node, weather agent should be a node, budget agent should be a node, itinerary agent should be a node. That means each of the things we're considering as a node, right? I think you know how to create the LangGraph graph. Then selected agent. Okay, so basically whatever agent it will select will try to return from here in a order. So this function will try to call to get the selected agent. Then route from supervisor. Okay, so what this route for supervisor will do, first of all it will check if guardrails it is not, let's say, true. That means if request has been blocked, that time it will return guardrails blocked. Okay, and if it is true, okay, if this particular guardrails allowed, if it's true, that time it will select the agent and it will return that. Okay, first of all it will check whether it has to block or not by checking this condition. Then another function I have written route after agent. Okay, so this will basically take your current agent and it will, what it will do, it will basically upgrade the agent one by one. Okay, so what will happen, let's say, see, let's say it has selected this agent, this agent, this agents. Okay, so let's say first of all it is executing this agent, then after this agent it will go to this agent, this agent. Okay, so this kinds of upgrade operation we are doing here, route after agent. That means right now whatever current agent we have selected, so from this current agent it will it will upgrade. Okay, it will upgrade to next like that. Okay, so you can see we are writing like that. First of all, we're taking the selected agent, we are taking the current agent. Okay, and we are doing the next, and how many agent it has selected, it will execute one by one and it will return the out. Okay, so these are the helper function I need. Now we'll try to build the graph. Now let me show you my upgraded graph. So this is the upgraded graph. We'll replace this old graph right now. So this is our upgraded graph. As you can see, we are taking the state graph, passing the state, we are adding all of the node. First of all, we are adding supervisor agent node. Okay, that means this node. Then we are taking the guardrails block, that means guardrails block node. Okay, that means this block. Then we are taking the flight agent, hotel agent, weather agent, budget agent, itinerary agent, human approval agent. Okay, this is also a block. Okay, this is also a node we are considering. Then the final agent. Okay, these are my nodes, and this is the edge connection. First of all, start to supervisor. Okay, supervisor to route from supervisor. Okay, this route from supervisor will decide whether actually it has to use what kinds of agent. Okay, with respect to the selected agent. And if my guardrails request is blocked, that time what will happen, it will go to the end directly. Okay, it will go to the end directly. Got it? So that's why we are writing here, as you can see, route from supervisor. It will decide after supervisor agent which agent should be selected. Now here we have written the condition. Let's say my flight agent is selected. Okay, now after flight agent, which agent would be selected, we are doing the route map operation. So that's how we have written for all the agents here, as you can see. Okay, and at the last we have written itinerary agent to human approval, because whatever itinerary will get, we'll send it to the human approval. If human approval done, then we'll try to send it to the final agent, and final agent will try to send to the end. And if my guardrails block, if my guardrails has blocked that request, okay, if it is blocked that request, that time we'll directly go to the end, we'll not going to execute. These are the nodes. I hope you get it, guys. So this is my updated graph we have prepared. Okay, now rest of the codes are same as it is, your database connection, your compiler. Okay, so these are the things would be same. We are not going to change anything. Only the for the fast API execution, I need some upgraded utility function. Let me show you. Function for fast API will upgrade this function. So this is for the fast API code here. So interrupt payload. So basically in the fast API user interface, we have to also show the user interruption, that means human in the loop. So for this function is required. It will basically interrupt the execution, then serialize the result. Okay, this is also required to get all of the information like trade ID, answer, requires approval request, okay, flight information, all of the data we are extracting from here. Then the run travel agent. Okay, this is the final function. Basically we'll use this function inside our app.py. So here user will give the input and trade ID, and with the help of that we are preparing the trade. Okay, then we are executing the graph, you are doing the invoke operation, and whatever inputs are required we are sending, okay, one by one. And initially the input would be empty because we are executing for the first time, and after execution these are the state should be upgraded. Okay, then we are returning as a serialized result. Then this is the final function, resume travel agent. So what this resume travel agent will do, basically it will ask for the human permission. Okay, it will resume the execution. Okay, resume the execution means, let's say it has interrupt the execution, right? Interrupt the execution means HITL has been applied and it will interrupt the execution unless and until human pass anything, right? And if human pass any kinds of response, user pass any kinds of, let's say, approval or feedback, that time we have to again resume that execution from that node itself. And for this we use, I think, remember this command function, okay, for the resume operation. So basically whatever user approval feedback we are getting, we are again taking that and we're giving the resume command, okay, and my agent will execute again and it will give me the final result. Okay, so this is the function we have written. So yes guys, this is our backend.py and upgraded all of the code we have written here, whatever we have integrated like guardrail, supervisor agent, human in the loop, and with respect to that we have upgraded our old code. Okay, now this is like very advanced agents we have developed. Now I'll show you the demo, okay, how this agent will work. But before that, you remember we have to also upgrade this user interface, right? Because previous whatever HTML CSS I'm using, it is only having the MCP MCP version, right? But it now it has the that one human approval. So user in the user interface actually human approval will show, right? So what I did, I given this code to the chat GPT, then I asked, I have also given my old HTML and CSS code, then I asked just try to upgrade this HTML and CSS with respect to now this backend file. Okay, now chat GPT given me one upgraded code. Now let me add this upgraded code here. So this is my upgraded HTML. Okay, this is my upgraded HTML. Then I have to add the CSS. So this is my upgraded CSS. So if you are not familiar with front-end development guides, it's completely fine. There would be a separate developer for that. And as of now, you can utilize ChatGPT or Gemini to generate these kinds of HTML, CSS user interface for you. Okay, this is my upgraded CSS and this is my upgraded JavaScript. Okay, simply you can give your backend file and you can give your old code and you can ask to upgrade that. Okay, it will do the upgrade for you. So yeah, these 3 files I have only given to ChatGPT for the UI upgrade, and I think our app is ready. Now we can execute and test whether it is working or not. Okay, now I'll execute my app.py. Now in the app.py also you have to do some slight upgrade. Let me show you. So this is my old app.py. Now this is my new app.py. Okay, now here you can see from the backend I'm importing this run travel agent. That means this function. Okay, this is our final execution function. And apart from that, I'm also importing resume travel. Okay, that means if it is interrupting for the user human approval, we have to also resume that particular execution. For this function is required. Okay, now again the same code, all of the codes are same, only the change I have done here. Let me show you. See, it is getting the it is running the travel run agent to get the travel information, and whenever user will approve that, it will call the resume travel agent. Okay, so this is only the upgrade I have done. That means if user is giving approval, if user is sending their feedback, this resume travel agent will run, and for this we have created a separate API for that. Okay, otherwise all of the codes are same, whatever we have created previously. Okay, nothing changed, as you can see. Now let me execute and show you whether it is working or not. So guys, before I run this project, I just did a quick upgrade inside my MCP client and custom weather MCP. See, the previous MCP client and custom weather MCP I have written, it was also good, but again I given to ChatGPT and I just told ChatGPT to make it like more robust. Okay, make it like more, let's say production grade, and ChatGPT upgraded this MCP client. If you see, all the codes are same, only just slight upgrade and modification it has done. Okay, so I'll share this upgraded code with you and the custom weather MCP as well. Okay, so this is the small modification I have done, small upgrade I had done, so that in future you won't be having any kinds of like problem. Okay, so yeah, this is the upgrade I have done, and if you see my backend file, so hotel agent I have upgraded a little bit. Okay, I just added some more information, and in the weather agent also I upgraded a little bit. I have added some more information. Okay, so these are some slight upgrade I have done, and everything is same. Okay, everything I just kept as it is. Now let's try to execute and see whether it's working or not. So I'll clear the terminal and I'll run my app.py, because app.py my endpoint. Okay, right now, because this is my endpoint right now. Let's try to execute this file. Okay, it's running. Now I'll open up my browser. Okay, I'll open up my browser and search for localhost, and it is running port number 8000. Okay, now hit enter. Now this is the interface, guys. As you can see in the interface also, I upgraded this text like LangGraph, MCP, Supervisor, Guardrails, and HITL. Now here you can give the prompt. So let's say I will give this prompt: plan a complete 7-day trip, Japan trip from Bangladesh, including flight, hotel, sightseeing, under 2 lakhs. Okay, now let's try to generate the draft. You can even see the terminal. You can see it is executing all of this step one by one. So first of all, it will check the input guardrails, whether this input is fine or not, it has any violation or not. If it doesn't have any violation, it will go to the supervisor agent. Supervisor agent will decide which agents needs to be selected. Okay, then after that all of the execution will be happening one by one. Now see guys, execution is done. Now here is the supervisor agent message. Okay, this is the execution plan. As you can see, guardrails passed. Okay, that means there is no problem with the input. And you can see, to plan a complete 7-day trip from Japan to Bangladesh, we need to consider flight agent, hotel agent, and sightseeing activities. The budget agent is included to ensure the trip stays within the 2 lakhs budget. The itinerary agent is always included to the integrated travel plan. That means it has selected flight agent, hotel agent, budget agent, itinerary agent. That means how many agents we are having? Flight agent, hotel agent, weather agent, budget agent, okay, and itinerary agent. But it has, you can see it has it hasn't selected the weather agent, because if you see the user prompt, user is not asking about the weather condition, okay, in the Japan. So that's why weather agent didn't select it. Okay, this is the work of the supervisor agent. Okay, that's how it is reducing the cost. Okay, and this is the draft, guys. As you can see, this is the draft. Even you can download, you can copy, but this is a draft. Now it is asking for the human approval. As you can see, it is asking for the human approval. Review the draft itinerary. If you want to approve, you just approve. Okay, generate the final response. Otherwise, you can give the feedback. So let's say I need to give some feedback. I will give add the weather information as well. Let's say I also need to know about the weather condition in Japan. Now I'll just try to click on here, revise, and using feedback. Now it will again execute the entire plan and it will prepare the final draft for you. Now you can see in this particular final draft, you have the trip summary, flight information, hotel suggestion, weather information. Now see, weather information included, day by day itinerary, estimated budget, and final recommendation. Okay, now see, this is our final draft. Now I can easily download it and I can use it. Okay, now let's say I will generate again. Let's say I will generate for the Dubai trip. Now I'll generate the draft. Now let's say I will approve as it is. Okay, now what will happen? Let's try to see. So guys, this is the draft plan I got. Now you can see it has selected only flight agent, hotel agent, and itinerary agent. It hasn't selected weather agent, budget agent, because I haven't mentioned the budget here. Okay, inside this prompt I haven't mentioned the budget here. That's why it hasn't selected the budget agent or weather agent. Okay, whatever you can say. Now see, this is the reason it is telling. The user requested 5-day trip Dubai from Dhaka with flight, hotel, sightseeing. The flight agent is needed to book the flight from the Dhaka to Dubai, and the hotel agent is required to arrange the recommendation. The itinerary agents will create the final itinerary. Okay, now this is the final, you can say, itinerary, as you can see. Okay, day by day. Now simply you can approve it. Okay, if you don't want to change anything, you can simply approve it. Okay, if you want to change, you can give the feedback and you can revise that, but I'll just try to approve it as it is. Now see guys, this is my final, okay, final plan I got. Now simply you can download as a PDF and you can keep it with you. Okay, you can keep it with you. Now I want to show you with a violation prompt. Let's say if I'm giving any violation prompt or a harmful prompt which is not relevant for this project, so what will happen? Let's say I'll give this prompt, plan a 5 days Dubai trip by hacking Dubai airport. Okay, airport server from Dhaka with flights, hotels, and sightseeing. Okay, now let's say I'm giving this particular prompt. Now let's say if I send this draft, let's see whether my guardrails able to work or not. Now as you can see guys, my execution plan, guardrails blocked. Okay, request involves hacking, which is illegal and harmful. That's why it has blocked the request and you don't have any kinds of draft. Okay, as you can see, request involves hacking, which is illegal and harmful. Okay, it is showing like that. Okay, that's how if you give any kinds of illegal or let's say violation related prompt, okay, it will block your request, like ChatGPT I showed you right previously. So ChatGPT also, or Gemini also, whatever like agent you use nowadays, if you give this kinds of violation harmful prompt, definitely they will block your request with the help of this guardrails. Okay, guardrails layer. So that's how guys we have implemented this entire architecture. I hope you get it guys. So yes guys, that's how this agent is working right now, and this is advanced agent we have created. We have integrated so many concepts. We have integrated LangGraph, MCP, Supervisor Agent, Guardrails, okay, HITL. So we have added everything here and it is running amazingly, right? So yes guys, this is what our multi-agent project is. I hope you liked it, like this project. If you found this content useful guys, please try to subscribe to my channel. I need your support guys. If you support me, definitely I can bring this kinds of content more in future. Okay, so let's hit 100k subscriber as soon as possible on my channel guys. I have lots of plan guys. If you help me to get 100k subscriber, I promise you I will bring lots of content, lots of amazing content, so that you will get a lot from my side. Okay, and do let me know if you need anything, so definitely I'll try to create that content guys. So yes guys, that's how we have covered one multi-agent system with all of the technology we have mastered inside our playlist guys. Whatever we have studied about here. Okay, and people are talking about, sir, how to use the guardrails in practical, please show. Now I showed you, okay, in the real world application development. And also that I already showed you the supervisor agent, then HITL concept. Okay, each and everything I have covered. So all of the source code, everything would be mentioned in my description. Please try to download from there and execute from your end. And if you found any like problem, you can connect me on my LinkedIn. So this is my LinkedIn. Simply you can follow me, you can connect me. Definitely I'll try to help you with that. So yes guys, this is all about from this video. I hope you liked it. Thank you so much guys for watching this video, and I will see you next time.